like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, hopefully you can hear and see me pretty well. Can everyone hear and see me? How are we doing on the hearing and seeing? I like Josh right there with the reverse emoticons. Everyone says it's good audio. We're doing great. Awesome. I'm audio and sound engineering today. I'm gonna bring up the audio just a tiny bit right there, so we got some louder audio. It seems pretty good. I think the mic's a tiny bit further away from me today. So now we got a little bit higher audio. So we are good. So we're gonna start today by working on the review assignment. We're still reviewing for test 2. So we got that stuff going on right there. Please turn the audio on. Everyone can hear us, right? I mean, so the audio is on. We have it pretty loud right now. And so I should be pretty easy to hear. And no one's saying can't hear you, can't hear you, can't hear you. And I have this on ultra low latency, so we look to be good. So awesome. Thank you very much, everyone. Alex and Serena and Bettel in the chat. Bettelham. So thank you all so much for being here. We're gonna hop into it. We're gonna get right into it. Let's see one thing. I'm gonna 99. Okay, who's gonna be my snap person today to make sure we're on ultra low latency? Because hopefully, I'm pretty sure I clicked that button. So you ready? Who's my snap person? Who's my snap person? Say me or someone in the chat. Is it gonna be you in the chat? Is it you? Say me. Who's gonna be my snap person? Oh, if no one's saying me, then I'm a little bit afraid we're not on ultra low latency. Me. So Hassam, you must type in the chat snap. And then, is this the thing live? It is live right now. We are live. So when you see me snap, you must write snap. Oh wait, I haven't snapped yet. I haven't snapped yet. So you have to do it when I snap. You ready? Here we go. When you hear me snap on the count of 3, you need to type snap in the chat. 1, 2, 3. That was a bad snap. So, oh, I'm sorry, Bettelham. We're on 3-second delay. We like that. I'm sorry. If you put the pronunciation, I'll make sure to get it right in the chat. I'm very sorry about that. I am bad with reading. And so we are on, when we get to the Kahoot, we got Red Bull today. I should get the green Red Bull so it disappears. So everyone can see me, and we're on a short delay. It looks like we're on the 3-second delay, which we like, because the long delay is a long delay. So let's start with the review. Is it Bethlehem? Sorry if I get it wrong there. I want to say it correctly. So let's jump over to here. I've never had Bang. I've never had that player. Oh, thank you very much. I appreciate it. There, Bethlehem. There we go. Got it. Get it? We'll get it correct. Let's do it. Hey, Julio, good to see you. Awesome. Let's hop in here. We're gonna start doing the review assignment to start. This will be a review over confidence intervals. Everyone is so excited in the chat. I love seeing it. Good seeing everybody. Okay, so let's talk about what we got going on right here. Let's switch over. Let's just jump into it. So we have right here the review assignment due tomorrow night. The due date is right here. So what chapters are on the test? Great question. Chapters are on the test are the following. We have everything from right here. Here's what's on the test. So we have randomness, we have sampling, we have probability, we have confidence intervals for proportions, and sampling distributions. So if you didn't hear all that, we're gonna drop over here. There's our interpretation of a confidence interval. So let's make sure it's clear for everyone hopping in. Starting off, we have randomness. So we have here randomness. Make people mods on the chat. So there we go, randomness. We have sampling. We have decision trees. Do not forget those decision trees. We have here confidence intervals. Well, let's do probability. Probability. We have here confidence intervals for proportions and sampling distributions, means and proportions. And I can't spell because it's got an R right here. Proportions? There we go. If I knew how to spell proportions, that would help. So here are the topics for the test. And there we are. These are all the major topics. What is on the test? Can everyone see and understand this? You should make sure you have a good understanding about everything with like how to do randomness problems, how to do sampling problems, how to do decision trees, probability, all this good stuff right here. There is a review sheet up on the Stat 201 webpage. I think a lot of people don't know about it, and they should. They should, we'll hop over here to sampling distributions, and we'll go to Stat 201 UTK, or stat201.utk. I'll check that out in a moment. Go here to exam prep, and you will see the exam prep. So if you're wondering how to do exam review, all of the exam review is located right here. It doesn't seem like that is much when you have it written like that. I know, right? It doesn't seem like that much. This is super random about what should we expect our projects to be graded. There are still about 90 projects to be graded, so we're getting close. I emailed the TAs about that today. So, and decision tree stuff is mainly just looking at the output of decision trees. You've got a lot of really good stuff here when you look at some decision tree practice questions. You can look at your homework assignment or your project for decision trees. Is there no decision tree on this test? Where's the answers? Oh, not who's removed. I would say watch the decision tree video then. I thought there was a decision tree on the practice test. But there are, we'll do some decision trees today then. Can we look at number 7? Yeah, I'll do it in a little bit here. And so all these great questions, here's the biggest thing. Is the formula sheet on the test? Yes, the formula sheet is the same formula sheet that you will get right here. Here is the exact formula sheet you will be getting on the test. So we can do some practice exam here in a little bit. Here's the biggest thing right now, and I want everyone to know this, that this assignment that I'm about to do right now is worth right now 10% of your grade. Now a few people have started the assignment, gotten a 0, not that they actually got a 0, but they have a 0 in there right now, but they noticed that it majorly dropped their grade. Each one of them is worth 5%, but the category is worth 10%. So if you do this assignment or don't do it, it can majorly impact your grade in a negative way. But who would like to get a major positive towards your grade? Since we in the online class do not have in-class quizzes, these are our in-class quizzes, are the reviews for the test. And it's very short, and so this is a great chance. And I think some people have already done this review assignment. Has anyone already done the review assignment and done well on it? If you're in my section, then you should have the review assignments, and if you've done well on it, great job. So many people told me, some people came by office hours today and they're like, yeah, it was easy, I did it. And I'm not saying it is easy. There we go, people have done it, me 100, yes. And it was easy, people are saying that. It's easy if you know how to do it, and that's the biggest thing. So we're gonna do it here today, and we're gonna talk through them because some people wanna just do confidence intervals. So let's start by going to the review assignment and reviewing confidence intervals to start. Okay, let's do some confidence intervals right here. It's due tomorrow night. Right now, all of your assignments are open till tonight, and then tomorrow night, this is due. People are saying easy, so don't forget to do this. Do it now. If you're watching the video right now, do it now. Why not? We're almost out of Red Bull. So we need a Red Bull delivery. The syllabus said something about if you get over 9 on your reviews, you get an extra point. That is correct. So this can be bonus on your final. Yes. So do these reviews right here. Make sure to be doing these reviews. These are very valuable and they won't take that much time. Olivia, you are right. So let's take a look. We want to construct a 95% confidence interval. Hey everybody. We want to construct a 95% confidence interval, and with this right here, we get a few things. Let's all work together to solve this. An insurance company checks police records and finds out on 556 accidents selected at random, condition 1, there are teenagers at the wheel 90 times. So let's think about this. What were we just given? What were we given for this assignment right here? It said in 556. What was 556? So there was no review assignment for the first test. There was no review assignment. What was 556? What is 556? Oh, no. Hey, Josh, for 1 second. Josh, let me make you a mod so that doesn't happen again. I wonder why it did that. I think it thought you might have been spamming emoticons. You can put emoticons, but sorry, Streamlabs can. So we have here n is equal to 556. I was like, who timed you out? And I saw it was Streamlabs. Streamlabs is an auto mod, and I'm sorry about that, Josh. You were timed out for 1 second. So if you had tried to type a chat in that 1 second, it would have been like, nope. So now we know what n is. And now we also know 90. It said teenagers were at the wheel in 90 of the accidents. What is 90? It says teenagers were at the wheel 90 out of 556. We have to practice our notation. Anna, you are right. 90 is x. And now what can we do with x and n? With x and n, x over n equals p hat. And just think of what p hat is. P hat is the sample proportion. P hat is the sample proportion. And so we get this right here. Great practice. If you're writing in the chat, 1,000 points, we're going to throw extra credit to the class right now. Keep giving these answers right here on what p hat is and what we're doing with this. And I want you to think what you're doing by finding this. With 90 over 556, you're telling me the percent of time a teenager was at the wheel in an accident. So when we do 90 divided by 556, we'd find that 16.18% or 0.1618, p hat is equal to 0.1618. Just think about what this is. This is the percent of time a teenager was at the wheel in an accident for our sample of 556. And the key word right there is that this is from a sample. And everyone typing it in, you are right. This is the sample proportion and what we observe. Now, on our formula sheet, we need to go to the confidence interval portion. So let's pretend we're taking this on the test and we have to go to the formula sheet. So we hop down here to our formula sheet. Here's our notes from last time. Oh, this one looks all crazy. So we're going to hop over here, wherever the formula sheet is, and here we are. If you notice, we have right here one sample proportions confidence interval. So X for Mary right there, thank you for the question. X represents the number of successes. There were 90 teenagers at the wheel in 556 accidents. So X is the number of successes. Imagine if you walk into a room and there are 2 people there from New York. I'm from New York and apparently 2 out of 10. So what would be the proportion of people in that room from New York if 2 out of 10 people are from New York? 2 out of 10 would be what proportion? And that's what we're doing right here. X would be 2, and Taylor, you got it right there. 2 is X because there's 2 people, and N would be 10. Just an example question there about what is X. X is the number of successes, and N is the number of trials. So X just represents how many successes. And then formulaically, we're going to use this one right here. Let me highlight it. I can't highlight it right on this. So we're going to get p hat, and let's hop back over to our notes. So now we just need to make the confidence interval. The confidence interval is going to be p hat plus or minus z star. We'll explain how to find this star here in a second, and we'll give some good news for the test. Here is the amazing news for all Stat 201 tests at UTK. So we're UT, we are the UT. Sorry other UT, you're not UT. But with this right here, we will give you the Z. Now, you can memorize these just for your own fun. I have, but a 95% confidence interval is a Z-score of 1.96, which is basically 2. We'll put these over here in the side notes that if you make an 80% confidence interval, it's 1.2815, 90% is 1.645, 95% is 1.96, and 98% is 2.3263, and 99% is 2.5758. What do you notice about the Z-score as we go up in confidence? You're welcome, Hannah. So what do you notice about the Z-score as we go up in confidence? What happens to the Z-score as we go up in confidence? So all Z's will be given to you on the test, or at least the one you need will be given to you. It gets larger because look at where it's at. It's part of the margin of error. So the Z-score will get larger because it's part of the margin of error and it'll make it bigger. You're more confident the interval is getting wider because this number is dictated by these over here. So when you change that number, you change the margin of error and you get more confident in your interval. But your interval will get less precise. Higher confidence, less precision because it's wider and wider and wider. So it'll get less precise when you increase the confidence. They're kind of inversely related right there. So you won't need to know all of those right there. So we'll continue on. Let's write our interval out. So we're going to solve this. We'll put p hat right here of 1.618 plus or minus the z star. I think it said 95%. I think it said 95%, did it? I cannot remember. It said 95% confidence, 95% confidence. We gotta make sure we found the right numbers. Did I use 556? I did. And now we have to go right here, and we have to go and put in 0.1618. Now, a lot of times people ask me, how do you find Q? So there you go. Come style up some more if you have still questions. Joshua, you are awesome. Thank you, Joshua. You are a great TA. So all TAs are excellent. We are now, what did I just find? I just did 1 minus p hat. You're saying it in the chat. And actually, this is 1 minus p hat. It is 1 minus p hat, not 1 minus p. Technically, this is p hat, because this is a sample proportion right here. I found the complement, which is q hat. Let's play the p hat, q hat game just for everyone to know who's watching the video. If p hat is 0.4, what is q hat? I want you to say in the chat. If p hat is 0.4, what is q hat? If p hat is 0.4, what is q hat? 0.6. So it just adds to 1. If p hat is 0.2, what is q hat? I love seeing the chat say this right here. If p hat is 0.2, what is q hat? If p hat is 0.2, now it's 0.8. Let's do a tough one. You ready for this? If p hat is 0.06, what is q hat? And you might need to pull out a calculator, but if p hat is 0.06, what is q hat? If p hat is 0.06, you got it. 0.94, you now know what p hat and q hat are. Same way it works for p and q. They're both complements. Nice job, Anna. Thanks for tagging me in the chat right there. Thank you so much. And oh man, you guys are doing great. So now we know what q hat is. All I did was subtract. We'll extend this out a little bit. We'll try to write as neatly as possible. I think it's that. That's basically it. That's good enough. It's enough decimals. And then we're going to put this over 556 because this is n. Please note that I am just doing the notation right here as it follows. When I go for n goes in the position of n because that's where n is at. So we're just using the notation above. Note that when I grab p hat, we solved for p hat. How much work do we have to show on our calculator? If you find out on the calculator, you are good. If you find it any which way, you are good. When we have p hat right here, we put p hat right where the interval goes. So if you notice, that is p hat, and that's where it goes in the interval right there. So just take your numbers and plug them in. Just understand the notation. Eric, you are doing excellent. We got some work to check on here. Eric looks to have solved it for us. And so now I'm going to do this in the calculator. I'm just going to solve out. Got a little place to put my pen. So let's do this. We got p hat and q hat. So I'm just going to do p hat times q hat over 556. Now, what did I just find? What I found right here, oops, square root, p hat times q hat over n, square root. There we go. With p hat times q hat over n square root, I have just found that portion of the equation. So this is the standard error. What I have found right now, ooh, Serena, you are right. That is the standard error of p hat. Taven, great job too. That is the standard error. Now we times it by 1.96, and we now have the what? I just timesed it by 1.96. Just look at what I've solved for in the calculator right now. Timesing it by 1.96 gives me what? And I think Eric's right. The margin of error. Everything after the plus or minus is the margin of error. Everything after the plus or minus, everything I'm showing you right over there, underneath that, it's in the plus or minus, it's the margin of error. It's also half the width of the interval because it's plus or minus that amount. So that is the margin of error. So think about this. It's basically 3%. If you look at Eric's answer up there, what is 3% or 16 plus 3% and 16 minus 3%? I want to do 16 plus 3% and 16 minus 3%. So you go plus or minus 3% from 16. 13 to what? If you look at Eric's answer, it's basically that. 19 and 13. You know what? Here, we got a few tries on this. It's probably not going to like it. My Pearson's a little more exact than this. They are very picky on their answers. Oh, it's percentages. Could we have done it? Could we have done it? My brother's calling. Could we have done it right here? Put him in a video. This, I shouldn't do it. Do you guys want to see if it's the right answer, if it would accept this? You know what it would accept? I bet if we round this, because let's just look at it right here. This is basically 16.2. It says 1 decimal. This is 3%. Like this whole thing right here is basically 0.03. That whole thing right there is 3%. I know it says to 1 decimal. Oh, I like doing it the last bit in your head, and then you get it wrong. But I am guessing it will accept this as an answer. It did. Just so you can see, it was close enough that it rounded nice and neatly enough to that. Let's see the answer over here on just looking at this. So what do we have right here? The margin of error is about 3%. So do you see this number right here? All we're doing now is we're taking 0.1618 plus that, and there's the top for the interval, which did round to 19.2, and then we're taking 0.1618 and subtracting from it that. And so that was nice. It gave me it with 13.1. Eric is exactly right. There was enough of a little bit of an error on it, plus or minus. I was like, you were close enough. But Eric was very correct. Great job. And so what I want you to notice is I'm solving the last portion of this interval now. I'm doing 0.1618, which is p hat, plus the margin of error. That's the margin of error. And then that's the upper. And then I'm doing p hat minus the margin of error, and that's the lower. So all I did was take the p hat, which is my hand right here, add the margin of error for the upper, and subtract the margin of error for the lower. Once again, confirming that it's half the interval. I added it to 16.18, and then I subtracted it from 16.18. And what did I add and subtract? The margin of error, which is basically 3%. And sometimes it's easier to think about without the decimals. It's basically, we could write this interval. Let's just look at it as a really easy way to write it. This interval is basically, for all intents and purposes, rounding decimals off of this, the interval is basically 16% plus or minus 3%, which gives us an interval of basically 13% through 19%. Basically. It's basically those numbers right there, basically. Does everyone understand what we're looking at here? That this is the proportion of times that teenagers are at the wheel in an accident. Now we want to bring the context to it. So how would we interpret this interval? What would the interpretation say? Grace, amazing question. Let's use this interval right here as the interpretation. And I've got the interpretation ready for us. So remember that 13 and 19, those are the only two numbers you need to know right now. Click the wrong button there. Let's head over here to this. Here we are. Here's our interpretation screen. So I am blank percent confident that the true blank is contained in the interval blank to blank. And I want you to try to write it now in the chat to see if you can write out the interpretation. So the first part number one, let's fill that in right here. Part number one is easy. That's just the confidence level you had. I am this percent confident, and I think we got some great answers in the chat. I think that's it. I'll read it in a second here. The second part is the hard part, but it's not that hard. Remember what we asked? We asked, how often is a teenager at the wheel? Nice job, all these answers in the chat. And then the third part right here is just your interval. That's all you're doing in the third part is just giving your interval. I am 95% confident that the true proportion of teenagers drivers that are in accidents is contained in the interval 13.1. And so let me read here. I am 95% confident that the true proportion of teenager drivers that are in accidents. Oh wait, so I am 95% confident that the true proportion of accidents involving teenagers. And so technically we probably give it to falls inside the interval. So let's see here. I'm 95% confident that the true proportion of teenage drivers that are in accidents is contained in the interval. And so I think specifically, Molly has it best. I am 95% confident that the true proportion of car accidents that involve teenagers is contained in the interval 13.1 to 19.2. Great job right there, Molly. Amazing job. 1,000 points to Molly right there. So great interpretation. I want to point out why. What were they looking at right here? They were looking at police records to see how often, yep, we're doing a class online on YouTube. Glad to have you here. So we're looking at the proportion of times that teenagers are at the wheel. You can turn it to percentage or decimal, either or. We'll know how to read it and interpret it. So make sure it's clear, like I am 95% confident that the true proportion of car accidents that involve teenagers is contained in the interval. Bam, nice job right there, JR, amazing interpretation. That's what we want to see. I know. You just find learning everywhere. We want learning to be at your door every day. So what we're doing right here is we're just interpreting the interval. So don't look at what they're doing. Look at our answer. Don't read what my Pearson has. They'll trick you. We want to give you the right answer here. We are 95% confident the true percentage, look at that. That is the only one that sounds like our interpretation, and we got it right. Oh, you rounded it as you said. Oh no, don't round it. I'm sorry. If you want to email me on that, if you got it off by a moment. Why am I transparent? I think did my hand go transparent? Sorry, I might have my alpha up too high. Slightly transparent. I might be disappearing. It might be Back to the Future. It could be. So about 95% of random sample sizes of 556 will produce, my body is? Oh, really? Oh, I think I see it. That's weird that it's keying in on that. Well, that's interesting. So about 95% of random samples of sample size will produce confidence intervals that contain the true proportion. So this is what, and let's talk about what this means right here. Good. Oh, we gotta do another one? Let's talk about what that just said right here. When we do confidence intervals, exactly. Oh, you missed it, Calzone. You missed it. We had some fun stuff last time. So what we're doing here with confidence intervals, let's make this as clear as possible. When we make a confidence interval, it's not about one confidence interval, it's about all confidence intervals. So what we would say is about 95% of 95% confidence intervals are expected to contain the truth. So whatever we're trying to estimate here, so what we're trying to do is we're saying a confidence interval is not about one confidence interval, it's about the process of making intervals. So about 95% of 95% confidence intervals are expected to contain the truth because one interval will contain the truth or won't contain the truth. You probably saw this in the slides. Our confidence is not about one interval, it's about making a bunch of intervals. That's what we're talking about. It's about I am 95% confident that in the long run all these intervals will contain it, but we don't really go into the specifics. This is what a confidence interval is doing. It's telling us in the long run what percent of the time these intervals will contain the truth. This right here is the interpretation. So this is interpretation. Interpretation, let's write interp. Interpretation, that's interpretation. Interpretation, and this is kind of descriptive. So this is the descriptive idea that 95% of 95% confidence intervals are expected to contain the truth in the long run. That's what we got going on right here. So that is what this question, just what it's highlighting right here, is it's highlighting that in the long run, 95% of 95% confidence intervals are going to contain the truth. So let's do the next one right here. A politician says, a politician, great person, nothing wrong with them. They say, in 1 out of every 5 accidents, a teenager is at the wheel. Do you believe their claim or not believe their claim? Look, what is 1 out of every 5? That's what percent? 1 out of every 5. What is 1 out of every 5? I need a calculator for that. 1 out of every 5 is 20. Whoop, it's not what it is. 1 out of every 5 is 20%. Do you believe that? Would you say, I don't know about that? Why would you believe that or not believe that? I wouldn't believe it because why? People are saying no in the chat. I still don't know why though. I don't know why. Maybe they're right, maybe it's 20%, but look at our interval. He's wrong, I like that right there. I would say they're probably wrong because it's outside our interval. You're saying to me, remember what your interval said. Your interval says, I am 95% confident the true proportion of time a teenager is at the wheel is contained in the interval 13.2 to 19.2. They claim it's 20%, so you're like, that's outside my interval. I don't think that's the truth. And since it's outside the interval, we would say, I don't think that's the truth. That contradicts what I saw in my sample. So super is 19.2. So we would say the interval contradicts because it's outside the interval. If something was in the interval, it means it's a plausible value. I like that right there, Taylor. He doesn't know. So the interval contradicts the assertion. It's outside the interval. I'm always afraid I'll read the question wrong and get one wrong. It's so easy to misread these questions. Oh, another confidence interval. Okay, remember, we're almost done with this assignment. So let's continue on here on how to make confidence intervals. But let's do a check on this. You ready? We have 3 conditions when making a confidence interval. Condition 1, what is condition 1? Anyone have any idea what condition 1 is when you make a confidence interval? Any ideas on condition 1? Condition 1. Elizabeth, let's make you a mod. Wait, did it? I wonder what that said. Condition 1, random. So it needs to be a random sample. So is it a random sample? If this, oh wait, Calzone, you are, sometimes we get people in here who find it and I'm so glad to have you. If you're learning stats, that's awesome. So random, we have a random sample. We passed condition 1. If I was writing this on a test, I'd be like, yes, it says that we passed condition 1. This is only for our class right here, Serena. Oh, did Elizabeth write that? Elizabeth, let's put her as a mod. I wonder why it blocked her. Yes, it's only for our class because our class is the online class, so we do like stuff like this because we're the online class. If for some reason she should be back, oh, cool, so glad to have you. Well, you can check out the rest of the stuff on our channel or email me at bs@utk.edu or bstevens@utk.edu. Either one gets to me. So feel free to ask those questions. We are glad to have you here. So we have here a random sample, and that is condition 1. Now, condition 2 is a little bit weird. Condition 2 is 10%. I want to see you be typing that in the chat right now. 10%. What does 10% mean? 10% means less than 10%. Hassam, nice job. So awesome, thank you guys. So less than 10%. We are doing less than 10%. What does less than 10% mean? It means that this 100,000 people is less than 10%. Now, you must assume that they have at least 1 million donors. Let's just pretend that it's like some national philanthropic organization, so they have access to all the US. So let's pretend the population is all US. Is 100,000 less than all people in the US? Is 100,000 less than 10% of all the US? And we would say, yes, 100,000 is less than 10% of the whole US, thus we meet the 10% condition. Now here's where we have to do what? I want to see you be typing in the chat right now. What do we have to do? What do we have to do now? I know my students are going to say it. We have to pause. We have to pause. Great job on the pause right there, because we're going to pause here and we're going to make sure that we slow down for the third condition. There are 2 third conditions we use. We could use success failure, or we could use large enough N. We could use success failure, or we could use large enough N. WS, you are right. So when we look at it to see if it's success failure or large enough N, we need to see if it's a categorical or quantitative question. This question is making a confidence interval to see the proportion of people who will respond to the mailer. So when I send out a mailer, someone will either respond or not respond. Does that sound like categorical or quantitative to say they respond or not respond to the mailer? Is that categorical or quantitative to respond or not respond? Is that categorical or quantitative? It is categorical because it's do they respond? Now don't be tricked by the numbers. It's not giving you the mean and the standard deviation and the shape of the distribution, which you would see for the sampling distribution of the sample mean, which is large enough N. This is going to be success failure. So condition 3 is success failure, and I think we have that in the notes from last time. So let's look over here at our notes from last time. Do we still have up those notes? No. Did we close those notes? Sad day. So we did have those notes up from last time on when to use large enough N and when to use success failure. We'll probably hop into that next. We're going to kind of do like whatever topic you want to talk about, and just so glad to have, if you're watching from somewhere else, glad to have you. So what do we get right here? We need to identify the notation in this problem. Well, let me just mention this. Success failure is met because we have 5,176 successes. And then what is the amount of failures? The amount of failures will be 100,000 minus 5,176. I cannot type today. There we go. That is the amount of failures. So we have this many successes and this many failures. So is quantitative large enough N? That is true. When it's quantitative, it is the large enough N. So great job there, Taylor. So when it's quantitative, it's large enough N. So continuing on, we have met success failure, we have met 10%, and we have met random. Random, 10%, success failure. All 3 conditions met. If all 3 conditions are met, what can we use for this? The normal techniques. So I know I like it. If you're practicing by jumping ahead, that's always good to make sure you are doing it right and you can check your work. So I appreciate it. So let's take a look. What is 100,000 in this problem? What are you going to do on your test when you see 100,000 right here? What will you do on your test? Now I suggest doing this on the test because remember you can get partial points. Put your notation on your test. What are you going to write next to 100,000? What are we going to write next to it? I got to see it in the chat or I don't know what to write. What am I going to write there? I'm going to write something right on it. I'm going to write n. You are right. Remember, we're reviewing now. What is this? We have how many people donated from the 100,000. What is that? How many people donated from the 100,000? That is what in notation? The amount that donated out of the 100,000 is going to be, the amount that donated out of the 100,000 is the one people always get confused on. The amount that donated out of 100,000 is what? X. Nice job, Eric and Serena and Alex. Great job, 1,000 points right there. It is X. Taven, nice job. Also, Laura and Brianna, thank you all right there because that is X. So guess what? We're going to hop back over here to our sheet of paper and we're going to write N equals 100,000. X equals, I think it was 5176. Now we can solve for p hat. X over n equals p hat. So just moving decimals, you can see that p hat is going to be equal to 0.05176. If you don't believe me, just solve it out. It'll be about 5%. Nice job right there, Alexis. So these are the answers. Check the lag. Feel like you are really behind. Reload the page. I do feel like we're behind too. Hopefully Kahoot might be interesting. So we might have to, good to see you. Thank you, Calzone. Swing by any time. So we're gonna write out our equation again. P hat plus or minus Z, P hat, Q hat over N square root. So now we're gonna solve for Q hat. Let's put Q hat over here. And Q hat is going to be equal to, we actually need it in there. Maybe YouTube's being a little bit slow today. Why? There we go. 0.94824. What was it again? 824, good. And from here, solve the interval. So, yeah, I think the chat can be a little, behind. So hopefully we're not doing too much of a latency. It could be the extra, hopefully we got a bunch of people watching. So we should be on the ultra low latency. 99% confidence, like we're faster than you. Weird, I don't know. You're faster than me? Oh, I think I'm just lagging behind. So 99% confidence, 160 good. Oh, that's awesome. Yeah, let's get some more Red Bull in this. Now we can wake up. I got it. What would be the Z again? Here's how we find the Z-score. One, you can memorize them, which I don't suggest. Or two, you can hop over here to the David M. Lane applet. On the David M. Lane applet, nice job, Jessica. On the David M. Lane applet, you can go here and graph the middle percent and use the Z-scores. And right there we get the 2.5758. You know it to the extra decimals. You've been taking track of these Z-scores. That Civ did save me right there. And so how do we decide what Z-score to use based on the percent confidence? And does everyone notice here we can go to a 90%? So if we go here, it's a 90%, 95, and look at the area being shaded as I go up. It just goes further and further and further out. And these will definitely be provided to you on the test. We will say something simply like the Z-score for a 95% conf roll is 1.96. Yes. You won't get a chart of these. We'll just tell you the one you need. So you won't have to search through. Because if we just told you a bunch, it would be like, okay, here's the one you need. We won't give you a Z table. We're just going to tell you the Z-score for a 99% conf roll is 2.5758. Or to 3 decimals, there it is right there when you round it. So you will receive these on the test. You will definitely receive these right here. So now we hop back over to here and we do 2.5758. That is the Z-score. We usually put a star on it, which means you get to select it. Good to see you, Anthony. And then we go right here and then we put our P hat, Q hat over N square root. Cracking me up. So we put that, and Q hat is right here. All the decimals, got it. And then we go here to 100,000. And that's got it. So, oh, you might want to hold off on the caps there a little bit. Okay, let's do this. let's go in and let's go right here. So we're going to do p hat, and here is p hat, and let's do 1 minus p hat. Oops, why am I doing that? Did that second time already. There's q hat. So, oh, it's not that bad. P hat times q hat over n. And now we do square root. P hat times q hat over n square root. And now we've square rooted it, and we're going to times it by 2.5758. What have we just found? What did we just find? What did we just find? What did we just find with that p hat? I just solved all of this right here. What did I just find? Everything after that is the margin of error. So everything after that is the margin of error. So great job right there. Everything after that, I just found the margin of error. So 0.0018. Nice, it didn't have that many decimals after it. That's got it. There's the answer. And I think Eric was giving it to us a moment ago, gave us the answer. So thank you, because this looks to be it. Let's double check right here. It's going to be, let's do it. Let's jump back into it. Okay, we're going to take this number. That's the margin of error. And we're going to subtract it from this. That gives me the lower bound. So that's 4.995. And then the upper bound is all these decimals, 0.05176 plus that right there. So that's 5.356. Is that what Eric got earlier? Is that what Eric got? Good to have you here, new jammies. The Kahoot will be closer to like 6:30-ish. 6:30-ish we'll start some Kahoot. So right here we have solved our interval. There is the interval. Let's check it out. 6:30-ish. Thank you so much. How did chatbot not? I know it has crazy settings. I need to like work on the settings on that, but I've got you guys here to help out. So I really appreciate it. What was the interval that Eric, I want to see if Eric, yes, Taylor and Eric, you guys came to the same answer I did, 2 decimals, 4.99 to, where did it go? It just was there a moment ago. There it is, 5.18. Oh wait, Taylor has a little bit different. She has the center right there, and 5.36. 5.36, that's the answer I came up with also, right? 5.36. And if it has a little bit, let me look at my answer on my answer page. It might actually round up to 5, it looks like. So we're going to be safe here, and we're going to put, I know this seems crazy, but watch this. We're going to put just 5 right here. So let's see right here. Does it like it? It does. Woo, that all rounded up. If you're wondering what I did right there, so double check your work. You should see that it should be symmetric around it. So everything I have right here rounds this up to 5, because the 5 rounds up, and then the 9 rounds up, and then the 9 rounds up, and that all rounds to 5. So this rounds right here to 5 to, so everything rounds to 5 to 5.36. So that is the interval when you round it, is between 5 to 5.36. And look at what's in the very center of this interval right here. In the very center of this interval, let's do a little red right here, is the sample proportion. P hat is at the center of this interval. It's about 5.18. So hopefully it's not buffering like crazy. We should have a good stream today with that. But p hat is at the center of it. How's buffering going? Are random people joining? Yep, because we are out there on the internet. That's the way it goes. So thank you guys for doing some great modding today. We'll put the code out there. I'll put the code onto the web page when we start the Kahoot. And we have basically almost finished up this question and done a pretty good review of confidence intervals. Who thinks 4.8 is plausible? So what right here? Do you think 4.8 is plausible? Is 4.8 plausible, yes or no? What do you think about 4.8? Is it, 4.8 is not in the interval, so I think 4.8 is not plausible, no, because 4.8 is not in the interval, and we've done it. Please realize if you are in my class, make sure to do this. This is a large portion of your grade. Austin, great answer. So Yes, it is not plausible because it's not in the interval. You're telling me, I think somewhere, I'm 99% confident the true proportion of people, let's do a practice, we need practice. Remember, we're trying to figure out the people who will donate to our philanthropic organization. So let's go over here, and I want you to write your interpretation right here. So let's see if you can write the interpretation for this interval with 5% through 5.36%. And the top part of it was 99% confident. So who can do it in the chat? This is your time to practice. We're doing lots of practicing for the test right now. So who can write the interpretation of the interval? Part 2 is always the hardest part. So who can do this? Can we go over some of the chapter 13 sampling homework and quiz? Yeah, sure. I think other people want that too. So who has this interpretation right here? I am 99% confident. We'll do a sampling distribution one after this. You guys can name it in the chat. I am 99% confident that the what? I am 99% confident that people will donate. Be careful. Remember the true word. True what? True what? True what? I am 99% confident that what? Who can do it? Really good practice right now for you to write this in the chat or write it down on your sheet of paper. The more you write this down, the more you say it, the more you practice it, you get to the test and you know it. So yes, Anna, you are right. So what do we have? Who's got it? I want to see at least one full answer in the chat to show me you are writing it down and you know what to say when you get to a test question like this. So, but what's the full thing? I am 99% confident that the true proportion of people who will donate after getting mailed is contained in the interval. Amazing job, Mary, right there. If you're in my class, 1,000 points. So, and I see these answers coming in right now. These are some great answers. I'm going to read it off one more time for you. I am 99% confident that the true proportion of people who will donate due to this mailing is contained in the interval 5% to 5.36%. And you can do 0.05 to 0.0536, the proportion. Either of those is fine. Proportions and percentages are just the original decimal or timesing by 100. So great questions right there. Let's do some transitions back here and get some more homework assignments up. So we'll just... Okay, so we're gonna pull up some more homework assignments right here. Let's do that. Let me get the homework assignments back open. Was there a particular problem people wanted us to do? A certain problem, any like the waitress problem, the pregnancy problem, the car problem, and what do I mean by problems here? These are just different Pearson problems. You get to name the problem, the pregnancy, car problem, waitress, bank loans, any of those right there. If you say it, first person to say it gets that problem done. The pregnancy one, are you a magician too? Oh, no, I think magicians are cool. Check out Amazing Randy. If anyone knows who the Amazing Randy is, he is absolutely amazing, and his name is Randy. That's two things about him. But check out Amazing Randy on YouTube. You'll see a lot of cool stuff. That's just Brian's advice being Brian. And let's go and do this right here. Okay, we're getting make sure I pull up the right one. Okay, cool. Oh wait, I have the wrong one open. I need to go to replace questions unless I get lucky and get it in my quiz. When we look at the quizzes, we actually have to go to replace questions, and let's take a look. That made you laugh. I have no idea what it was. Okay. Okay, so we're almost to, I'm pulling up the one. Oh wait, I'm on conference rolls. This is our interlude right here, between moments. Chapter 13, sampling distributions. Place questions. You will get the Z-scores. Thank you very much, everyone typing that in the chat. There we go. Okay, here we are. And I think I saw the pregnancy one people wanted. And I'm almost there. We'll get a cool transition again. We got it. Let's hop back. Okay, we are back now. So we have the pregnancy problem up here. And let's think about what's going on right here. Now, here's some keywords I want you to zero in on. This problem right here is actually a review problem for Chapter 5. Thank you, Alex. This is a review problem for Chapter 5 using the normal curve. So what do we have here to start? We have some David M. Lane stuff. So let's take a look at this right here. And notice that it says that pregnancies are what? Normally distributed with a mean of 262 and a standard deviation of 12. Does that make sense to everybody? normally distributed with a mean of 262 and a standard deviation of 12. Anytime you hear the normal model being used, you should think 68, 95, 99.7, meaning we can go say hey to our friend Mr. David M. Lane, and here he is right here. So I forget the numbers immediately, but we're going to need them. We need the mean of 262 and the standard deviation of 12. Now, a lot of people say to me, well, how can I solve this if I don't have this on the test? You can draw this out. You can always draw this out. Let's talk about what we're experiencing here with this drawn out. Is all we are doing is we're putting at the very center of the curve. I wish I could walk over there. Well, can I? Watch this. It's too much work to walk over there. At the very center of the curve, all the way over there, at 262 is the mean. And then we're going up and down 12. That's when you saw me put in 12. This 12 right here just changes the number. Now the number above 262 will be 272, because the standard deviation is the amount of units you will go up and down. We'll do the newspaper poll one next right here. So if you notice here, this is the amount of standard deviations we are going up and down. So we're just drawing the normal curve right here. So the next few questions will be a little bit easier. And I might do this. Watch some magic here. Let's go ahead and take, I can't put that in a window. Well, darn. It says what percent of pregnancies will be between 270 and 275? So we go back to David M. Lane, and there's the YouTube channel. And we go between 270 and 275. So between 270 and 275, and if you look, it's going to shade in the area between about here to here. So maybe about 13%. How close was I? 11.32%. On the test, and I'll explain how a test question would look with this, but this question right here really wouldn't be an amazing test question yet, and you'll see why. So we'll show why here in a moment. So let's change this to a decimal. It says round to 1 decimal. I think this is the one I got wrong last time because I put in 2 decimals. So that is rounded to 1 decimal right there. We changed it, just times it by 100 and just put it to 1 decimal. What is the longest 25% of pregnancies? We're going to go back here to the curve. Now we're going to go to where we can put in the value from an area, and we're going to graph 25% right here, and we're going to graph the longest 25%. So far, this kind of wouldn't be a test question so great for this test because this is a Chapter 5 question, but it does something important in just one moment. So we now have the answer right here. Hey-oh, is that Jason?
That's me.
Hey, Jason. You want to say hey? We got almost 200 people watching today.
Oh, wow.
How many people are we at, chat, right now? How many people are we at? Maybe we're down to 10 people. They'll tell us. I hope I did ultra low latency. We seem to be on about a 5 or 6 second delay. It's probably just gonna. Jason. Hey, Jason.
152.
Yeah.
Hey, always remember, people.
Wait.
You need batteries. You gotta have batteries. So there you go. There you go.
Thank you, Jason.
Yes. Oh no, dropped one.
I told Jason my one worry was in the back. Thank you so much, Jason.
Yes.
I heard someone come in and I was like, who is it?
Yeah.
Chroma loves you, Jason.
We have batteries, people.
We maxed out at 173. We almost had 200 in here.
Wow.
I know, right?
Yeah.
Okay, so thank you so much, Jason. Good to see you.
Yes.
So now let's take a look at what we have going on right here. That was a guest appearance. That was a guest appearance. Can we do that? We'll do some more here in a moment. Okay. So, okay, so here's where the problem gets real. I know, like, he's so clean shaven right now. I'm too, there we go. So, Chroma, we're here for you. We're here to help you with mathematics. So with this right here, this problem now changes from a Chapter 5 problem to a Chapter 13 problem. So the problem now changes from a Chapter 5 to a Chapter 13 problem, because now this problem is talking about the sampling distribution of the sample mean of sample size 20. Does everyone notice right here that we have the sampling distribution of the sample size of 20 women? This is the sampling distribution of the sample mean of sample size 20, which is different than just one woman. But I want you to think about this for a moment. If one woman has a pregnancy of 262 days, then what would you expect for the mean of the distribution? For 20 women, one woman has a pregnancy that lasts 262 days. What would you expect the average of a bunch of women's pregnancies to be? Taylor, you are right. It is 262. And you might be saying, how did you get that? Well, one, there's a formula for it, but just kind of thinking about it theoretically speaking, that if we have here the distribution, I think we lost it for now, or we'll go over here to this slide. If we have here, so much notation, and this slide makes it look all crazy. Good, these ones actually look decent. We're talking about the average for, there we go, this formula right here. The sampling distribution of the sample mean is going to have a mean that is equal to the mean. Remember earlier where we said 262 is the mean? Well, that is the mean for the distribution of the sample mean. And the standard deviation is going to be the original standard deviation over square root of n. The original standard deviation over the square root of n. So that's what we have going on right here, the original standard deviation over the square root of n. So let's go ahead and take a look at this problem now. Thank you, mods, right there. So we have right here, what was the original standard deviation? The original standard deviation was what? It was only 12. So now we're going to take 12 and divide it by the square root of what? 12 divided by the square root of, you should be saying in the chat right now, 12 divided by the square root of, yep, and we push things back just a little bit to help out to make sure you got help on it. So 12 divided by the square root of 20. This is the new standard deviation. So the new standard deviation is what? That's too many decimals. The new standard deviation, and thank you right there, Tav's amazing in the chat. The new standard deviation is the original standard deviation over the square root of 20. That's the formula you just saw, and let's write it down right here. Let's make it very, very clear. So what we have right here is that the mean for the distribution of the sample mean is equal to the mean, whereas the standard deviation for the distribution of the sample mean is equal to the original standard deviation over the square root of n. Sigma is the original standard deviation. Saying something like the standard deviation for these women is 12 is sigma. N was the 20 women we took a sample of. Nice job, Julio, right there, and Laura and Brianna. Now let's change this up and let's see something we should know. And we'll be using these more. Mu p hat is equal to p, whereas SD p hat is equal to p times q over n square root. You've heard me say that a lot by now. Now, what is the difference between the two of these? This one is quantitative, and this one is categorical. The difference between quantitative and categorical data. Can you do the wagers one next? Yeah, let's do that. We'll do a bunch of these right here. I think a lot of people want practice on these, and maybe, hopefully, we'll see if Kahoot's working, because I think the timer's a little bit, or we're lagging by like 10 seconds. Might have not done ultra low latency. So this right here, we have the mean is equal to the mean, the standard deviation is equal to the standard deviation. Now here's where people make mistakes on this problem. The last question is about the mean for these 20 women. So do you know what you need to do? You need to take this standard deviation and change this one right here. Let's go here and go to this and change it. The standard deviation is now this, which is tighter. And let's change this one here to the new standard deviation. Does everyone see I'm doing a new standard deviation for a sample of 20 women? The mean stayed the same because the mean is still the mean, it's still the average, but the standard deviation got tighter by a factor of the square root of n. So now I think it asks for the longest what percent of the women? We need to go over to this one. So it says the longest, what is the probability these pregnancies last less than 268 days? This was the one I got wrong last time because I went the wrong way on it. And we want to go less than 268. So let's go here and go less than 260. Did it say 268? Really? Wow. If that is it, it's going to be like 100%. Well, that's going to be interesting. I feel like something is a little off here because that is, oh no, it's not 100%. I was looking at it wrong. It's going to be very large, though, very large. Below in section, thank you very much. Tabs right there helping out. It's really easy to look at these things the wrong way. It's a very high probability, and you just have to make sure you're using the distribution of the sample mean. And I'm going to do one little review on that right now here in a moment. Let's take our answer, round to 3 decimal places, drop it in, and that's not going to round up. That's going to stay the same. Check answer, 100%. We like that 100% right there. It's very easy to make a decimal mistake on these. You guys know I can make it. You have to be careful. Is it saying above or is it saying below? It's very easy to make a decimal mistake or graph the wrong way on these. So great job. I think we wanted to do, I don't know if we've done the waist size one lately. So let's do the waist size one. That's one of my favorite ones. It looks really tough, but when you understand what's going on, it's actually very interesting. So the waist size one, I think there was the voting one and a lot of these different ones. Here we are. Now this one looks super complicated. It looks way more info. But here's what you have to know. That this 36.31 is what right here? That is the mean of waist size of men. And then we have right here that this is the standard deviation for these men. So this is for a population right here, the true mean. You see where it says true mean? That's the true mean. So that's the true mean and the true standard deviation for all of these people right here. That's the true mean and the true standard deviation. If you notice that these ends are less than 10% of that population. So that is the mean and the standard deviation for that population. So let me ask you this crazy question. Oh, Colin, you got it right there because the standard deviation is going to change. If you were to take a sample of, let me ask this, if you were to take a sample of one man, what would you expect his waist size to be? What would you accept? You just take random one man, you'd expect his waist size to be what? Probably gonna say it had, you'd expect his waist size to be what? Just a guess, like what do you think the waist size of one guy is? What would it be? Any ideas? Just 36.31. How about if we took 2 guys and averaged together their waist size? If we took 2 guys and average together their waist size. 2 guys and average together their waist size. What would be 2 guys' waist size averaged together? Hey, it's the same answer. And what we're seeing right here is the following. So we can take 36.31 and just copy, paste, what? Can't show history. Let's go paste, paste, paste. Got it. 36.31 would be the average for all of these. Someone might be saying, well, why does that work? Well, we wrote it down. We wrote it down right here, that the mean for the distribution of the sample mean is equal to the mean. That's what that means. Thank you doesn't matter. We're always here to help. So we have right here that the mean for the distribution of the sample mean is equal to the mean. So this doesn't change, but what does change, and we heard it earlier just a second ago, I hate when I undo it, it goes up. What does change is the standard deviation. The standard deviation is the original standard deviation over the square root of n. And here's where people make a mistake. Don't use the simulation, use the original standard deviation. That sigma right there, sigma is the O with a little circle on top of it, the standard deviation is going to get smaller by a factor of the square root of n right there. So we have that right here, that the original standard deviation over the square root of n, kind of picture-in-picture stuff going on right there. So we go back over here and we take our original standard deviation, and all we're going to do is do the square root of 2. I'm going to move this a little bit away from myself right here. Let's do, where's square root of 2? There we go, lost my mouse. So we're going to go square root of 2, and the original standard deviation was 3.99. There we go, 2.82. 2.82. Take the next one. This is like the boring part of it. 5, square root of 5. All we're doing is taking 3.99 and dividing by the square root of the sample size. So we got this right here. We're taking 3.99 divided by that right there. It's just the square root of the sample size. So 1.78. So what are we going to do next? We're going to do the original standard deviation of 3.99 divided by the square root of 10. So I have to do square root of 10 on this calculator first. And then we're going to take 3.99 divided by the square root of n. What do you notice about the standard deviation right here each time? Who can tell me in the chat what is happening to the standard deviation as n increases? As n increases, what is happening to the standard deviation? Be thinking about that in the chat, because it's one of the rules of the central limit theorem that states as n gets larger, this should be happening to something here. So all I'm doing is doing 3.99 divided by the square root of 20. The standard deviation gets smaller because it gets tighter by a factor of the square root of n. You are right in the chat. And I want you to look at these numbers. Now once again, whoa, hit a wrong button. So all I did for all of these problems was I did the original standard deviation, which is right here highlighted. So I took like 3.99 divided by the square root of 20. So all I did, each problem, 3.99 divided by square root of 10, 3.99 divided by square root of 5, 3.99 divided by square root of 2. If you notice, as n gets larger, which is the bottom part of the equation, it just gets tighter and tighter and tighter and tighter and tighter. That's what's happening due to the central limit theorem. The distribution of the mean will get tighter than the original distribution. We'll draw that in black right here. The original distribution will be more spread out, but the distribution of the mean gets tighter and more normal, the two things that the central limit theorem says. Distribution of the mean will be tighter and more normal as n increases. And I want to point this out, that this chapter right here is about the sampling distribution of the sample mean, which is what you see right here. This is the standard deviation for the sample mean. This is the mean for the sample mean. This is the mean for the sample proportion. This is the standard deviation for the sample proportion. And we've got two separate parts to this right here to identify the different sampling distributions. I've kind of divided this screen right here so that you can see categorical on one side and quantitative on another. Now it does still work that as n gets larger here, the standard deviation will get smaller also. So you do have multiple attempts on these quizzes. You should have like 5, and also the big one we put on ours, you have multiple attempts. So what do you notice? Do these numbers match the numbers over there? And they are pretty close. Here's a tricky one, and this one is oh so tricky. So we're going to look at this right here. We're going to zoom out a little bit. Here is the theoretical. Now, here's the thing. This would not make for a good test question right here. We'll do the newspaper poll one next. You got it, tabs. So when does this look normal enough? Now, the third condition here is what? Random, 10%. And then what is the third condition for quantitative data for the sampling distribution of the sample mean? Remember, it's quantitative because it's waist size. We're asking people their waist size, and people know the answer in the chat, and they're saying large enough. You are correct. It's that n needs to be large enough. Look what happens as n gets larger. Why is it called large enough? Because as n gets larger, it gets more normal. That's why we're saying large enough. So apparently, it's large enough at 5. That's what we have going on right here. Now, I don't know if I would have guessed 5 the first time I did this. I don't love this question for that reason. That's probably one of the hardest things to answer on it. But the answer is 5. And remember, you can see what you get wrong in quizzes, and that does not change as far as I know. It's usually 5. Not usually, but it's always been 5 every time I've done it. On the test, you might say, well, how are you going to test us on the test? On the test, we're going to ask you if it's normal, then what sample size would you need? I'm not saying we're going to directly ask you that, but if it's normal, we need a sample size of at least 1. If it's skewed, we need a sample size of at least 30. If it's heavily skewed, we need a sample size of at least 100. So the rules are, if it's normal, let's go to blue pen. Normal, sample size of at least 1. I didn't do what I wanted to do. So normal, at least 1. Let's just do at least 1. 1 is good enough. Skewed, 30. And very skewed, 100. You need to ask yourself 3 things. 1, what is the shape? 2, what is the rule? Put some question marks on these. What is the shape and what is the rule? So if it is normal, the sample size doesn't matter. 1 is large enough. If it is skewed, then you need a larger sample like 3. 25 is fine also. Could you say 25? Sure. That's the thing, and so in higher order statistics, we have more exact ways to do this. So it is like 25 and 30 are kind of tomato, but we'll usually make it very clear on the test. If you look at one of the true-false questions on the test, it says something about a sample size of, I think it is, let's look at this right here in practice. Let's do this on the test. Let's look at a test question with it. And then 3, do we pass? I want you to try to write a sentence So does everyone see your 3 steps? Have these 3 steps written down for checking the large enough. 1, what is the shape? 2, what is the rule for that shape? And 3, do we pass? And I think we have some more. We're going to do a bunch of these right here, Mark. You got it. So what is the shape? Let's look at the practice test question to see what it says. So here we go right here. Okay. Suppose the heights of females between 16 to 18 are normally distributed with a mean of 66.25 and a standard deviation of 2.1. If repeated random sampling from this population, the central limit theorem implies that a sample size of 2 will result in a sampling distribution that is normal. So the question really here, it's saying 2 is large enough that this distribution will be normal. Is 2 large enough? Is 2 large enough here? Remember your steps. What steps did we just say we have to do? Step 1, what is the shape? Step 2, what is the rule? Step 3, do we pass it? So let's see. What is the shape? Who can, and I think he'll get in the chat, but what is the shape of this? What is the shape? What is the rule? Do we pass? Colin, 1,000 points right there. I haven't given a lot of points today, but Colin, you got it. What is the shape of it? What's the rule for that shape? And do we pass it? It is normally distributed. It needs a minimum of 1 samples, 2 passes. Anna, amazing answer right there. So Serena, great job too. It is normal. And so a lot of people were confused. They'd say, wait a minute, 2, how is 2 large enough? And it's because it's normal. So since it's normal, 2 is large enough. And basically, it'll just get more normal. So if it's normal, audio, we're good? Okay. There we go. So yeah, audio's back. Yeah, no, that's why Jason came by. Jason is the man, so everyone give a big thank you to Jason. I told him we had like a few sets of batteries left, and I was like, I'm gonna be going a while tonight. We're gonna be doing a lot of reviewing. So, and I actually heard it kind of go. So thank you to Jason once again for bringing it. I'm using a wireless mic here, and the receiver ran out. How's my battery doing on this mic? It's still got 2 batteries on it. Well, my wireless is here. Jason is the man. Dead account 2018, you know that. All the people in the chat. So the rule is, I typed be right back, but then I didn't hit enter. Can you explain the rule portion again? I'm confused on what rules you are talking about. Good question. So what rules are we talking about right here? Basically, each shape has a certain like size we need for it. So sorry about my handwriting down there. That's why I type out a lot of things I have to write. So, oh my gosh, let's see if I can make it look nicer. Here we go. If anyone watches this video, I actually want it to look halfway nice. So 1, what is the shape? 2, what amount do we need for that shape? 3, do we have that amount? If we do, we pass. So if you look at this right here, this might help you understand. It's not really a rule. It's just like, how much do we need such that the distribution of the mean will be normally distributed? And so let's get this all on one screen here. I'm going to erase that all down there. Let's go back to draw. Let's go to erase. There we go. Okay. So here we go. Here is the long and short of it, because we can, there we go. Can I get out of eraser mode? I bet if I do this. So these are, there we go. These are what you need to be talking about right here for this, for the following. Well, there we go. So what is the shape? The first one right here is normal, the second one is skewed, and the third one is very skewed. So the more skewed it is, the wider n needs to be. The more skewed it is, the wider n needs to be. That's kind of why we call it the condition, because the more skewed it is, the larger n needs to be. The larger the sample size needs to be. You're getting it in the chat. So the more skewed it is, the larger n needs to be, which is kind of going back to this question here. And I think some people wanted some more homework questions on here. So the distribution of the original data, it's not bimodal, it's unimodal and somewhat symmetric. I wish it said somewhat symmetric, so it does not take a very large sample. It's not heavily skewed. If you look at this original data, it's just got a very, very light skew, which I know we'd think a higher one, CO2, and we'll do CO2 one next. Got 100%, woohoo, got it. Let's do CO2 one next, CO2. So the CO2 emissions one, I think people wanted waitress one next. So the CO2 emissions one. Okay, let's slow down and think about what equations to use on this. Like, let's pretend it's a test question. You ready? Since this is a test question, it says the mean and standard deviation of the distribution are 2.692 and standard deviation, Hannah, you got it, waitress next time. So Hannah, if I don't do waitress next time, you say, Brian, you said you do waitress next time, so we'll do the waitress problem. So the mean is 2.692 and the standard deviation is 0.8, and then newspaper poll. So now we have these right here. A company has 70 cars in its fleet. Now here's one thing that this problem should tell us. It should tell us the shape of the distribution. The shape of this distribution, let's say, is skewed. So we're taking less than 10% of the cars, of all cars that exist. We are going to also take a random subset of cars, and then we are also going to see that this is large enough because 70 is larger than 30. If you review the previous thing we just did, I'm pretending that it says it's skewed, and so a sample size of 70 is large enough that this distribution will be normally distributed, which actually helps us answer the first question. If we meet, and here's a great note for you, if we meet all conditions, then we will have normally distributed data. The whole point in checking condition 1, 2, and 3 is to use the normal techniques. That's why we're doing the conditions. If we meet the conditions, the distribution of the sample mean in this problem will be normally distributed with a mean of 2.692 and a standard deviation, if I could type, and a standard deviation of 0.8 divided by the square root of the sample size. You might say, how did you know it's 0.8 divided by the square root of the sample size? It's because of all this right here, and let's make it a little more clear. So we're going to kind of go to a new page. We don't want to lose that. So we'll go to a new page right here, and the reason is because the mean for the distribution of the sample mean is equal to the mean. The standard deviation for the distribution of the sample mean is equal to the original standard deviation over the square root of n. So we have to take the original standard deviation, which I can't remember off the top of my head right now, and divide it by the square root of 30. The original standard deviation was 0.8, and divided by the square root of 70 is the right answer. So we're going to take 0.08 and divide by square root of 70. That is our new standard deviation. The original mean stays the same. Just like the waste size problem, if one car has an emissions of this on average, then we'd expect the average of a bunch of cars to have an emissions of this on average. So the mean stays the same, no need to solve that right there. So let's do square root of 70, and then we're going to divide 0.8 divided by the square root of 70, 0.096. And we're just going to copy paste just in case. We're almost done with this problem, because now that we have the standard deviation, it says round to 3 decimal places. Put that in right there. And now we're going to take all of this right here and bring it over to the David M. Lane applet. And let's pretend we have to do this on the test here for a moment. So I'm going to put in the standard deviations first. Here's all the standard deviations. And then we need the mean. All I'm doing is just taking my mean and standard deviation and putting it into the applet to help solve these problems. Now remember, you can draw this out. So let's ask this question. What percent of cars are expected to get more, or what percent of the time would we expect to see a sample of 70 have on average an emission of 2.788 or higher, and look at where I'm picking, what percent of the time would we expect to see a sample of 70 cars have an average emissions of 2.788 or higher? So what percent of the time? And you should try to figure this out right now to see if you can follow along. I'm going to do this right here. We're going to take and we're going to snip this, and we're going to bring it over to Word real quick, and we're going to draw on it. So you say, how would you figure that out? Well, let's bring it over here, and let's drop it in. So you're getting in the chat, you got it, because what I'm going to do is I'm going to go below this, I'm going to write the Z-scores. This is what I would do on your test. Please, on your test, write your Z-scores, because now we can do the 68, 68, 95, 99.7. So what do we want? We want the following area. So that is what the test question could ask you, theoretical test question right there. So with this right here, if 68 is inside here, what is total outside? If 68 is inside, what is the total outside? What is the total outside? We were reviewing for a test, Ryan. Good to have you here. So this right here, what is the total outside? What is the total outside? Is Hannah, let's make Hannah a mod. Oh no, was Hannah unright? If Hannah was unrightfully done, like removed, then we'll make her a mod. Sometimes, sorry if Streamlabs a little hyper. This is an example problem right here. What did Streamlabs do? Streamlabs, well, darn. Hannah, if you can type something, I'll make you a mod. So that way, I think you were unrightfully Streamlabs went after you, and I don't know why. I know it. Oh, no, I trust you. Oh, why can't I make you a mod right now? Why are my mod powers gone? Do I have too many mods? Sorry, don't worry, Hannah, you're fine. Streamlabs is just really picky sometimes. Oh, it might have been like some sort of weird thing. Yeah, and we'll be doing Kahoot here in probably just a little bit. Probably a little later on the Kahoot. We might have too long of a delay to do the Kahoot. So a question is like, how did you get this right here? This is a fake problem we just made up, where on the test it might ask you, what percent of cars are expected to have what percent of 70 fleets of cars would have an emissions above 2.788? And this is for a fleet of 70 cars, not for one car. Does that make sense? This distribution you're looking at right here is for a fleet of 70 cars because we took the original standard deviation and divided it by the square root of n. So I think they're following along right here. We have to have this one due tonight because we have the quiz due tomorrow. Make sure to be practicing this up. This one is due tonight. Tonight is the last chance right here. So now let's go ahead and let's take and drop in the problem. We'll do the waitress, then we'll probably do some Kahoot next. So now we're going to do estimate between 2.8 and 2.9. So we need to do between 2.8 and 2.9. And I'm going to have everyone vote here. Should we do more homework problems or go to Kahoot soon? I'm going to keep streaming. You guys get to vote. I'm here to help. That's what we do. Now it wants the top 1%. We go over here. And remember, what I have right here is I have my mean and I have my standard deviation. I'm just going to find the top 1%. We got people saying Kahoot, Kahoot. We'll probably do some more help after this in a moment here. I think we have the waitress problem round to 1 decimal. See, I'm going to get that one wrong if I don't round it. Round to 3, round to 1. Hopefully I haven't done these too quickly. Check answers. Woo! I think we did the waitress problem in a previous one. Waitress, then Kahoot. I think let's do the waitress because I did promise that one. Yeah, Tabs is right. We did the waitress one last lecture. So we did, Hannah, do you have access to the last lecture class? If not, I'll send you the link to it. But we've done waitress, so Kahoot, please. Okay, so let me see. What happened to my button here? I used to have a button that would turn me on and off. I think I can turn my audio on and off. I can mute my audio. So let me get the Kahoot up and running right here. Have to walk off screen. So let's see. how can you do B and C of this one without plugging it online? That is a great question, and the answer is you really can't. You can make estimates, you can do it with a calculator, but that's why we kind of came up with this question right here, using the distribution to say, what percent of the time would we expect a fleet of cars to get an emissions average above 2.788? So Kahoot should have you freely log in, and so let's see, sorry I'm walking off camera here for 2 seconds. I'm going to load up the Kahoot. Be asking those questions. Let me hop back to the main screen here. Okay, we're back on the main screen now. Sorry if I walk off camera for 2 seconds, like I keep on hopping off. Ask questions in the chat while I'm setting this up right here. I'm gonna put the code in the usual spot. There we go. So on the test, it would be like nice numbers. Natasha, you got it right. On the test, we give you nice numbers like Z-scores. You can use normal CDF on your calculator, definitely. And if you see that the TA takes off points, please tell me. Be like, Brian, I used normal CDF and I got an exact answer. That's perfectly fine. The exact answer to that one is something like 15.84, I think. If you did the one we just did, it'd be like 15.84 on the David M. Lane applet. But we're fine if you use empirical rule numbers, or if you know how to use normal CDF, which we don't really teach, which is fine. It's just, it'll get you an exact answer. We feel sometimes that you can use the applets to get the right answers, and then on the test we want you to use empirical rule, so you kind of have some knowledge with you. You can always kind of make an educated guess with the empirical rule numbers. You're welcome. Great questions. Keep asking those questions as we get the Kahoot up and running here. So you'll see it on the page where it's usually at. You know where to go to. Those are in the previous videos. Sorry, everybody. Maybe we'll do more after the Kahoot, but we're going to keep how do we get on the Kahoot. The Kahoot will have the code on here. And let me change this over right now. So if you're here, you know where to go. Don't go over to the previous video. Let me delete the previous video. All right, so I'll have the Kahoot started up. Let me jump over here to, okay, I've got the Kahoot. One of my fears is the name generator on, randomized order of questions, randomized order of answers, show minimize instructions, automatically go through questions, off, require players to rejoin. Okay, enable personalized learning. What is that? Okay. Let's see. Okay, so one moment right here. So we've got the Kahoot up. And you know what? Let me see. Okay, so I have updated the page. Can we use the stat test prop? Yeah, you can totally use those, Nicole. So you can totally use those. Try to make it so the code isn't on the screen. You are right. Oh, yeah. Wait. Don't, okay, wait. Okay, wait. Adriana, you're right. Okay, that Kahoot's over. Let me update. Don't go to that Kahoot. I put in 000 as it. Where's the display the code throughout the game? Okay, I think, is there a button that says display code throughout game? Sorry, everybody. Ooh, there's new lobby music? That's cool. Randomized order questions, show minimize instructions. Okay, I'm gonna have to put a block up at the bottom of the screen. That's gonna be interesting. I think, give me 2 seconds. It's at the bottom. Where's it at on the bottom of the screen? Give me just one moment, because I'm gonna have to set this up. We'll be starting in about 2 minutes here, so, because I'm gonna have to set up a quick block on this. So let me do the following. Let me go right here. Let me go to new. I'm gonna grab some purple. Okay, we got a purple block. So let me look at how the Kahoot looks. Sorry everyone for the tiny bit of a delay right here. I just want to make sure we don't have the same issue as last time. So we're just relaxing for a second right here. Where is the Kahoot game at the bottom? It's on the bottom left, is it? Okay. So then what I'm going to do is File, Save As, Purple. Okay. Then I need to go back to this screen and let me load this up right here. So let me, okay. And let's go to plus, okay, image, add source, dark gray. I think we have that already loaded in. So let's go to dark gray. Oh, look at that. Got dark gray right here. And let's make this nice and big. It might block me out just a little bit right here. So we're just adding in a nice little block. And there we go. I might be blocked off a little bit now, but sorry, there we go. Now we won't get people. So can everyone, code isn't up right now, right? Because I couldn't not show the code, but we have right here the dark gray screen covering up the bottom. So sorry, I'm gonna be, oh, you know what I can do? Let me click on myself and sorry, there we go. And click here, oh, I'm unlocked. Oh, there we go. So now I'm above it. We just gotta make sure this isn't covering up too much. And okay, so 2 moments on the code. Sorry about that, everybody. Let me hop back over to here. I was just trying to make sure we have it so that we don't get spam botted. Please don't spam bot us. People can do it in the class, but don't do that. That's no fun. Anyway, so now, okay, so now I'm gonna have the code up. Let me hop back over to here. The code is coming up. 9 something, I didn't say that. Okay, the code is up. The code is up. So don't put the code in the chat, whatever you do. Mods, if you see it in the chat, please delete it immediately. So mods, if you see the code in the chat, please delete it immediately. We should start seeing, let me make sure I got it right. We should start seeing people joining in. Please tell me if it says like invalid. We see someone, please don't spam us, whatever you do, because then we're just trying here to learn. That's all we're trying to do. That is our goal, is to be a learner. So we are just here to learn. So it's where it's usually at. It's at our place. So we got 24, 25. All the people right here. We'll give it another minute or 2 more. We're doing fine. It's got some spooky Kahoot on it. So yep. Do it. So trying to think of the best way. It's where it's usually at. It's on our homepage and everything. So we have 119. That's awesome. Let's get 100 people in this Kahoot. So please leave it up for everybody. Yeah. So awesome. Let's see here. So whatever you do, don't Kahoot spam us. That's not to make it fun. It is Kahoot time, Julio. So thank you, Adriana and Julio and everyone. We'll give this another minute or 2 more, and we're going to do the Kahoot. We're going to cross our fingers that the latency isn't too slow. Please reload. Just hit reload on the stream maybe to make sure. Oh, of course, you know it. It is Kahoot time. Kahoot is back. What do we got going on right here? Oh, you know it. There we go. It's funny, I don't get to hear the noises or else they'd feed back through a loop. We don't get to, yeah. We've got 105 people in, 200 people watching almost. Thank you everybody for being here and for watching. I'll probably cut over it to once the Kahoot starts to make sure we're blocking the thing at the bottom. I think it's blocked. I raised it up a little bit. I should probably raise it a little bit higher. It's on our homepage, Emily. Emily, if you can email me really quick. Emily, let me see here. I might be able to email you really quickly. So 2 seconds, 112. We'll get started here in about 1 or 2 minutes. Oh, that's awesome. Good to see you, Gerard. Thank you, Gerard. We appreciate that. So, okay. Emily, you should have it. Okay, check your email. 118. Right when I email it. Okay, so we got it. Awesome. Thank you so much. Good to have you. No, we love having everyone visit and watch. Got one last sip of Red Bull. Enough power to get through the evening. Right there, Red Bull. We got it. So let's do it. Okay, here we go. We're gonna hit start on the Kahoot now. So remember where everything's at. And so let's hit start, and we're doing great. Now I'm gonna cut over to in just a moment here because I'm just gonna make sure it's being blocked, which I think it is. Okay, let me cut over to it. Good. Let me raise this up a little bit right here. Cool, I'm gonna make sure it's being blocking it. Okay, good, I'm gonna lower it down a little bit. A researcher lists all roads and then randomizes the order and selects the first 50. Now be careful, they are randomizing it. This is key right here. They take all the roads and then randomize it and select the first 50. Now be careful, what's going on right here? They take all the roads, randomize it, and select the first 50. I know it says first, I know it says first, I know it does. What's gonna happen? What's gonna happen? The answer is simple random sample. What is simple random sample? This is a simple random sample. Why? Because when we do a simple random sample, we select randomly. So we can give everything a number. Imagine if I gave everyone here a number. Like just give yourself a number 1 through 100. Like any number you want, 1 through 100. Just a random number. Give yourself any random number you want. So if everyone had a random number randomly generated for them, 73 right there, 53. These are all, we're pretending, random numbers. Everything gets a number, right? And then since these numbers are random, the first 50 would actually be random. We're going to be reviewing a lot of these sampling methods right here. So I know once you do it, you're in. I'm sorry. I'll be dropping hints as the question's on here. Now watch as the countdown goes. Sometimes it's a little bit off. Yes, if I picked the first 50 roads on a list, that would be convenience. But we took all the roads and randomized the order. So now the first 50 are random. It's a little bit of a trick question that we had on the test one semester where we randomized the order of it. And I purposely picked this question on here. So, so this right here, these are, the first 50 here are random. Does that help make sense? The first 50 here are random because we took all the roads, randomized them, and then we have the first 50. What are the steps in simple random sample? So right here, the steps for a simple random sample are 1, give everything a number. 2, select randomly. So if you randomly give everything a number, you could select the first 50. Imagine this, I go around class and I say, pull a number out of the hat. And people who get numbers 1 through 10 are winners. Would that be a way to have people randomly win the prize? If I go around class with a hat with numbers 1 through 100, and you pick a number, and if you get 1 through 10, you're a winner, would we get random winners then? Even though you're only using the first 10 numbers for winners. And Heidi, I think you were right. I hope Streamlabs didn't come after you there, but Heidi, you were right. And for some reason, I can't make more mods, which is driving me crazy. Did I max out on mods? I might have to go back and delete people from previous semesters if so. Oh no, Heidi, please ignore Streamlabs. I'm gonna have to cut down on it. It thinks you're posting links, but you're not. We don't want people coming in here posting random crazy stuff. So that's why Streamlabs was a little hyper. I put the filter up higher, just so if someone were to come in here and say some stuff we didn't want them to, it would do that. Sorry, Streamlabs. Streamlabs needs to calm down. Streamlabs, you're timed out, Streamlabs. You need to calm down. So there was a question, can we talk about clustering and strat before we continue? Here's the notes you need on clustering and stratified. Clustering is when you take a whole bunch at once and then you do a census on the cluster. So when you take a cluster of sodas, you'd be taking 12 packs of soda. Does that make sense? That's a whole bunch of sodas at once. When you take a cluster of donuts, you'd be taking a dozen donuts at one time. That's a whole bunch of donuts. How about a cluster of students? What's a cluster of students? You want to take a whole bunch of students at one time, you'd take a what? To take a cluster, you take a whole bunch at one time. It has to be a random group that's a whole bunch at one time. A cluster of students would be like a what? A what of students? A class. But remember, this is just a random group of students. So a cluster is like taking a class of students. But and be careful, if we're doing seniors, we might be stratifying, because we wouldn't want to take all seniors because that would not be representative of students. Grade level would be stratifying. Major would be stratifying. Because when we stratify, we start by acknowledging a difference. So when you see strata right here, strata means to acknowledge a difference and then take samples in accordance to that difference. So that's what we would have right here. Could a cluster of fans be a stadium, or would that be too large? That'd be really rather large. You might say, imagine, oh no, the Patriots, oh no, after last night. Imagine the Patriots wanted to know what their fans think. Could the Patriots go and take a row of fans at the stadium as a cluster? Not yet, I can't even make mods right now. So could the Patriots go and take a row of fans? That would be a cluster. But think about this, some fans sit in kind of like the first class, like skyboxes. So skyboxes versus seats in the stadium would be stratifying because you'd be acknowledging a difference right there. What about the student section? Student section versus regular section, is that cluster or strata? And hear what I said, student versus regular section. Would that be cluster or strata? There's a student section and a regular section. That'd be stratified because you just acknowledged a difference. To get a representative sample of Neyland Stadium, you wouldn't want to take all the student section. That wouldn't be a bad cluster because that's not a random cluster. You would take some from the student section and some from the regular section, the non-student section. That's stratifying right there to say, let's take some from the student, some from the regular. You're acknowledging a difference, and then you sample within the strata. When you take a cluster, you take the whole thing. A row of people in Neyland Stadium would be a cluster where student versus non-student is acknowledging a difference between groups and is stratifying. Does that help make sense of strata versus cluster? We'll have a few more on it to make sure you know what's going on. You got it. So let's continue on right here. Thank you, everyone. Keep that positive energy going. Remember, there is a $10 Starbucks gift card for the winner and a $5 for second and third place. So cluster is a random group selection, but stratify is choosing group based on differences. Correct. Don, right here, the clusters are randomly put together. Like you'd have to say, I know it's not 100% true, but imagine you were to look at all the rows in Neyland Stadium, and you were to take maybe 20 random rows in Neyland Stadium. That'd probably be a good way to get a whole bunch of people sampled, is to take 20 random rows. So the rows would be clusters. Now you might say we probably need to stratify a little bit, and now you got a multi-stage, because you might say we need to take maybe a few rows from the box seats, we need to take a few rows from the student section, and a few rows from the non-student section. So by doing the by grouping, saying we need to go by this and by this, that's stratifying, but taking the rows itself, the whole bunch at one time, where you're like, well, let's just take a whole bunch without any differences acknowledged, is a cluster. Can it be 10 bonus points instead? What if you took major of college? Major is stratifying because you're acknowledging a difference. So does that really help with strata versus cluster? Like taking a plane of, like a whole group of passengers from a plane is a cluster of passengers, but then taking people based on first class versus economic versus business is stratifying because you're acknowledging a difference. A plane is a whole bunch of passengers, but then if you stratify, you would say, well, we want to take some first class, some economic, and some business because we don't want to have too many first class, too many of this to not have undercoverage bias. Good review there. Let's do another question. Get ready. Here we go. Next question on the Kahoot. We got Rocky Wildcat in the lead. Next question. The list of roads the researcher has access to sample. Keyword right there, we're accentuating that. The list of road the researcher has access to sample. The roads they have access to sample. So these are the ones they could theoretically. It's not the ones they sample. Hint, hint, it's not sample. Remember, I'll keep dropping hints. It's not the sample. And it's not all roads they want to understand, which would be the population. So the list of roads they have access to sample would be the what? All the roads they could theoretically take from, that they can actually get to, that they could maybe get data on, would be the sample frame. The sample frame, have these definitions written down. The sample frame is all people or things we could theoretically get access to. No trigonometry today. So the sample frame is all people or things we could theoretically sample from. How about if you were to hang outside UT Library and talk to people? If you were to stand outside UT Library, what would be your sample frame? And just think what it means. The things you have access to. Oh no, reload the stream. Just hit that reload button and make sure you're as on pace with us as you can be. So the people coming out of UT, probably students, more specifically, the students you would have access to are students coming in and out of the library at that time. You wouldn't talk to all of them because to talk to everybody would be like, you'd be like, hey, wait a minute, you can't leave, you need to talk to me, you're coming out of the library, you gotta talk to me. Theoretically, you could stop everyone and say, you can't leave unless you talk to me, but theoretically, you could talk to everybody. Not everyone's gonna be in your sample. People walking by the library, Lindsay, great answer right there. That would be your sample frame. Those are the people you could theoretically talk to. Now the people you talk to would be your what? Would be your what? What would be the people you talk to who actually talk to you? They'd be your what? The people who talk to you would be your what? They actually talk to you, you get data on them. They are now in your sample, you are right. Now think about this. You want to understand UT students, that makes UT students your who? UT students, I'm losing my hand right there. UT students is your what? UT students is your population. So UT students would be your population. The students you speak to are your sample, and the ones you could have theoretically spoken to, like the ones walking in and out of the library, are your sample frame. Think about it, you're just making a frame right here and you're picking from it. You're picking things out of this frame. Everything inside of it is something you could sample. You might be asking, what is the parameter of interest? Maybe you're asking them, do you like Taco Bell? I love Taco Bell. So do you like Taco Bell? And you want to understand the proportion of students who like Taco Bell. Think of this, parameter of interest. It's what you want to understand about them. So the parameter of interest would be the proportion of people who like Taco Bell. So one, you want to understand UT students. They're your population. You talk to UT students coming out of the library. They're your sample. Theoretically, you could have spoken to anybody coming in and out of the library at that time, making the people around the library at that time your sample frame, the ones you could have theoretically spoken to, the ones you had access to. And then last but not least, you ask them about Taco Bell, so you want to know the proportion of students who like Taco Bell. What is the blanket definition of population? All people are things you want to understand. All people are things you want to understand. Everything you get data on is the sample. The sample frame is everything you have access to sample. Oh, that Baja Blast, Ryan, if you're in my class, you get 1,000 points right there. Baja Blast is amazing. And parameter of interest is the thing you want to understand about the population. When I had Baja Blast, it changed my life. That was, man, that green blue drink, whew. I'll be like, I don't know if I want Taco Bell, but I do want some Baja Blast. So I think you can only get it at Taco Bell. Damn them and their Baja Blast. Let's continue on to the next question here. Remember, we'll have some more review questions on these and keep asking those questions in the chat. Next, let's do it. Quiz question time. A researcher selects every 5th rows, technically starting at a random starting point. So the key here is, you need to get some Baja Blast, Nicole. So the key here is they're going to take a 5th row starting at a random starting point. Every 5th row at a random starting point. And just a review question here, is population of interest and parameter of interest the same thing? No, population of interest would be the people or things you want to understand, synonymous with population, and parameter of interest would be the thing you want to understand about the population. So that's got it right there. Nice job, systematic, that's why I was kind of reviewing the question right here. Great question, Addie, right there. Once again, to answer the question specifically, population is the people or things we want to understand. You can call it the population of interest. It just means the population you're interested in. Parameter is the same thing as parameter of interest, which is the same thing as population parameter of interest. Listen to the key word right there, parameter. Parameter means what you want to understand. It's what you're measuring, the parameter you're measuring. Of interest means this is the thing you care about. And population, parameter of interest means the thing you care about for the population. So if you want to look at the key words, population, the people or things you want to understand, parameter, what you want to understand. That's the what of what you're trying to study, the parameter. Hence why we call it parameter of interest, the thing we want to study. Systematic has 2 key steps. 1, start at a random starting point. Take these notes. And then 2, pick every kth element. And everyone seemed to get that, so we went a little quickly there. Are you ready for a next one? Let's do it. Let's hop in here. I can't find the mouse anymore. I lost the mouse. Where did it go? With 2 screens, the mouse can get lost so easily. Let's continue on. Fabulous Wombat, keeping the lead right there. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P hat? What does P hat stand for? What is P hat? And it would be P with a little hat over it. P hat, I think, is the sample proportion. And wait a minute, we have 30 freshmen out of 200. So wait a minute, 30 out of 200. I think 30 is X, that might come up later. And 200 sounds like N. So 30 over 200 is 0.15. That is P hat right there. P hat is the sample proportion. We got it. So if you put 0.20, 0.20 is technically P. Because the question says we know UT is 20% freshman. That makes that one P. So a lot of people might have gotten tricked right there. P hat is always X over N. It will usually we'll put the little hat over it. Kahoot doesn't like hats. So P hat is the amount of successes. Oh no, I'm sorry, Natasha. P hat is the amount of successes over the amount of trials. And so remember, take these notes, that if we know that 20%, did you guys get knocked out of the game? Can you jump back in? It timed out. Oh, did you guys run out of time? Are we on such a long delay here? Reload the stream. Make sure you've reloaded the stream. Hit just refresh in the top corner, and you'll probably jump to where we're currently at. So refresh the stream. Refresh the stream. Does that make sense? Just hit the reload button, hit the little circle reload, or Command R or Control R. So let's see a snap delay. You ready? Let's see how long we're going on it. You ready? 1 1000, 2 1000, 3 1000, 4 1000. Well, you guys got to know to type snap. No. You ready? Have snap typed in the chat. Someone's gonna type snap. Oh, we're on like a 10 or 12, 15 second delay, I think. That's what I was afraid of. That's like a 16-second delay. No wonder. Oh no. That's 16 seconds. We must not be on ultra low latency. Let me try something here real quick. Can I change the latency of the stream while we're streaming? Can it be done? If it can be, that'd be amazing. I think once the stream is streaming, I can't do that. I'm gonna try something here real quick. You don't think it's that bad? Okay, then we will give it a shot. Here, we're gonna just do a quick check right here if I can change it. I'm checking over here on the other PC. We're dual PCing right here. Live events. Edit. Okay, 2 seconds. Sometimes you have to hit the live button when you're realizing it went off live. Yeah, when I ask you questions, you answer pretty fast, like 4 seconds. Yeah, so make sure let me see my snap. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. 5 second delay. We are on ultra low latency. Make sure, so we are on ultra low. I'm getting a 5 second delay over here on my end. So it looks like, oh, there we go. So make sure you're on live. So does everyone, we're seeing it. So refresh the stream to make sure you're with us. Okay, you guys ready to hop back into it? So if you are typing snap, I had like 5 seconds, then you're good. So refresh the stream, hit the refresh button in the corner. Awesome, here we go. I'm gonna fall over. Let's do the next question right here. Some of these might have a longer thing. Combo breaker, no. We know UT is 20% freshmen. We sampled 20 freshmen and 30 report being freshmen. What is P? P is the true proportion. P is the true proportion. So what is the true proportion for this? You might have to be quick. Remember, it's asking you what is P. P is the true proportion. When you're seeing this right here, what is the true proportion? Any ideas on what the true proportion is? Any true proportion guesses right here. Any true proportion. And did people able to get their answers in now? What is the true proportion? There we go. Nice job. The true proportion is 0.20 because it tells you, and that's what P is. Here's the thing that we're practicing right now. We need to know what notation is. When you look at each of these questions, it'll say things like this, like we know 20% of UT is freshmen, so that would make it 0.20. So there you go right here. It might give it away. I think Emily's going for the win right here. So let's continue on. Let's get to some harder questions. I don't know if I randomize these because we might hit a few. Here we go, quiz question. Which of the following is a rule of probability? We got some probability rules coming up. So we have quantitative variables, QQ straight enough, no outliers. Wait, those don't sound like the rules. I'm not saying that they are or not, but we have rules of probability. So Tabs, you're just so good at it right here. I appreciate it. So you're fine. Rules of probability are that probability. I am definitely still dusted. Oh, it's over here. So the rules of probability are that probability has to be contained between 0 and 1. And so think about this. Here's a big thing. Whenever you solve for P hat, Q or Q hat, they must be between what? Because they're proportions, which are probabilities. Whenever you solve for P hat, Q, or all those numbers, they must be what? They must be contained between what and what? Anytime you do P hat, Q hat, so they have to do that. It's a gray shirt. I don't know why it's picking up. So they must be between 0 and 1. Sabrina's catching back up. She's on stream now. So right here we have that probabilities contained between 0 and 1. Also, the sum of all probabilities has to equal to 1. That's a key probability right there. So all of these rules are the probabilities between 0 and 1. We have the complement rule, we have the addition rule, we have the multiplication rule. Let's try another question. Get ready. Here it comes. Next question, Fearless Jaguar in the lead. Two events that have no influence on each other. Two events that have no influence on each other are what? They do not influence each other at all. They do not influence. Oh, there we go. I love all those answers. So with this right here, two events that do not influence each other. That means like, I know that you made an A in stats. What does that mean my brother made in his course? If I know you made an A in stats, would that tell me anything about my brother making an A in a course that he's taking? So, oh no, Megan, no. So think about it. The two events would be independent. What does independent mean? It's a good question, Natasha. Remember, we're here to learn, so please ask those questions when you have it. Probably an A+ because we won the prize right. You are right. So we have right here that independent means if you know A, it tells you what about B. If you know A, it tells you how much about B. So imagine two events that are independent, like you know it's snowing today. Does that tell you anything about, let's say, the price of tea? You're like, it's snowing today. Does that tell me anything about this? So it tells you nothing. How about this? It's snowing today. Does that tell you anything about that we might have school or not? Is snow and school, are those independent events? Like the probability of snow and school, are those independent? And we'll do all of these right here. I see people in the chat being like, what's this one? Are snow and school independent? Like the probability of snows and the probability of school, are those independent? Those are dependent. Those are very dependent events. The probability of snow would then, if it snowed, would change the probability of us having school. So does that make sense? And we'll do all these definitions right here, right now. So if two events are dependent, it doesn't mean you know that it snows that we didn't have school. Not a UT, Alex is right. So it means if it snows, the probability of school would change. As in, we have school maybe 99% of the time, but when it snows, the probability maybe goes down to 20%. So it would change the probability of us having school if it snows. Now you wouldn't say if it snows, we wouldn't have school. It's just that, so sometimes we get school off. One time we had off on my birthday, which was awesome. We got to play video games, just have a nice day and sledding. So these will be on here, and I might be able to, if you know a way to get them off Kahoot, email me at bstevens@utk.edu, and I can send them to you. I don't know if there's a quick way to do that. Now let's look at the other ones. Disjoint. What is disjoint? Now when you think about what disjoint is, I want you to do this. Here is disjoint. What is Brian doing by doing this? I'm basically showing you a Venn diagram, if you've ever seen those, where things do not overlap. If they overlapped, they would have a joint. So what does disjoint means? It means if A happens, B cannot. Imagine you ask your friends, we're going to do some sad topics here. They say, did the Patriots win last night? And you say, no, they lost. So wait, they say, no, you didn't tell me if they won. You say, well, they lost. But think about this. Winning a game is disjoint to losing. As in, is if you lose the game, you cannot win the game. So a disjoint event means if one happens, like if event A happens, event B cannot also happen. Think about this. Other disjoint events are your grades in a class. If you get an A in a class, just one class here this semester, can you also get a B? Can you also get a B if you get an A? The answer is no. Can you get a C? The answer is no. Grades are disjoint because if one happens, it can't also happen. What would be non-disjoint events? Can maybe you be a student at the University of Tennessee and born in New York? What about losing the game and going to the Super Bowl? Can you lose the game last night and still go to the Super Bowl? Those are disjoint or not disjoint. Emily says, can you lose a game and still go to the Super Bowl? So can you lose a game during the regular season and go to the Super Bowl? Let's check. Can we lose a game during the regular season? Can we also go to the Super Bowl? Can we lose a game in the regular season and also go to the Super Bowl? If we do this, which we will, because you can lose a game, you can still go to the Super Bowl for Patriots. They're still doing well. Seasons were doing fine. I know defense was doing amazing. It was unprecedented. And then last night, it was still good. I mean, you lose every once in a while. So you can lose a game and still go to the Super Bowl. So since both of those can happen, it is not disjoint and that they're not mutually exclusive. Disjoint and mutually exclusive are the same word. So they are considered dependent. That is very true. In other words, disjoint events are dependent because if A happens, B cannot happen. Did everyone hear what Alex just said? So if, let's say, can you lose every game in the season and go to the Super Bowl? Can you lose, I like right there, we got some mathematical probabilities right there. Can you lose every game in the regular season and go to the Super Bowl? Can you lose every game in the regular season and go to the Super Bowl? The answer is what? Can you lose every game in the regular season and go to the Super Bowl? You cannot. You cannot lose every game and go to the Super Bowl. So those would be disjoint events. Does that make sense right there? It is disjoint events because you cannot lose every game and go to the Super Bowl. This is the way to do disjoint. If this is what you do, if you say yes to one and the other has to be no, they are disjoint. Independent, you have to think about. Does winning a game influence you going to the Super Bowl? Does winning a game influence you going to the Super Bowl? Yes or no? If it does influence it, then they are dependent and not independent, which dependent means not independent. Does winning a game influence you going to the Super Bowl? Yes. So they are not independent. Winning a game is not independent of going to the Super Bowl. So remember, to do independent, you have to ask yourself, if A happens, does that influence B? You have to ask yourself that question. Great job. We're glad to have you here and learning. So when you do independent, say, event A is the Patriots win a game. Event B is they go to the Super Bowl. Does winning a game influence you going to the Super Bowl? Yes. So that would mean they are dependent. Going to the Super Bowl is dependent on winning games. So they're not independent. Can you win a game and go to the Super Bowl? Yes. So they are not disjoint events. Correct. Jessica says, didn't you say disjoint and mutually exclusive are the same thing? Those are synonymous words. Think of what mutually exclusive means. It means there's no overlap between these two circles, like this is A happening and this is B. If they're mutually, the two of them, exclusive, they would not do it. What would be not disjoint? Mutually inclusive when the circles overlap. So great questions in the chat. Good review right here of probability rules. And if two events are independent, what can we do with them? I want to see it in the chat. I want you taking these notes. If two events are independent, what can we do with the two events? We can what with them? If their two events are independent, we can easily what them together. I don't know why my little on-off button for me doesn't work anymore. We can multiply them. Alexandria, you were right. If two events are independent, we can multiply them. And if two events are disjoint, we can add them together. So I'll just give you that one right there. If two events are independent, we can multiply them easily. And if two events are disjoint, we can easily add them. There are some advanced rules for probability, but we just focus on the easy ones, that if two events are independent, the probability of A and B is just multiplying. If two events are disjoint, the probability of A or B is just adding them. So just some really simple rules of probability. But if one event causes the other not to happen, disjoint, doesn't that mean they're dependent because one depends on the other? Yes, let me double check here. If one event causes the other event, that is very, very correct. Like losing all your games in a season would make it impossible to go to the Super Bowl, making losing all your games dependent. You are very correct. Disjoint events are completely dependent because if one happens, the other can't happen, so that makes them completely dependent. Like going to the Super Bowl would depend on you losing all your games because once you lose all the games, you're not going to the Super Bowl. So disjoint events, good note right there, are completely dependent. Making an A in the class depends on making a B. Jessica, great note. Disjoint events are dependent because if you make an A, you didn't make a B. Making an A depends on making a B. If you make an A, you can't make a B. Does that all make sense on disjoint, mutually exclusive, and independent? Great review of these concepts right here. I think we're good. Good stuff. Remember to keep asking those questions. And I do have a really good review video on this too. There's a lot of review videos on the Stats 1 website of all the chapters. Be watching those if you want. So let's continue on here. Fearless Jaguar. The roads the researcher wants to understand, these are the roads they want to know. These are the roads they care to understand. They're like, I really want to understand these roads. What are these roads they want to understand? They said, we need to get data on these roads. Not just like these specific roads, but like roads in Knoxville. What are the roads they want to understand? Now, they might not get all of them. That'd be a census. A census is if they got data on all of them. But these are the roads they just want to get data on. The roads they want to understand, the things they care to know, would be the population. The population is all people or things. Now, people are writing the parameter of interest. That'll be coming up here soon. The roads they want to understand is I know it's a little bit hard to understand. Thanks for the review. So good to have you, Morgan. Thank you very much for the compliment. These are the things they want to understand. It's not what they want to understand about the roads, it's the things. Now I know you usually think about people as the population, but if we want to collect data on roads, so be taking a note, it'll be coming up, it'll be potholes. Potholes is what we want to understand about the roads. It's really hard to write full, long questions out here. Oh no, good to have you back. Parameter of interest would be what about the roads they want to understand. Bailey, you are correct. Nice answer in the chat right there, Bailey. So there we go right there. Craziness. And we will continue on. Please ask those questions. Remember, we reviewed a lot of these concepts, but keep asking. This is a tough one right there. Thank you. Calzone, we are so good to have you right here, and we appreciate you. I like that people are joining in. And then the researcher takes too many city roads in their sample. And I'll let you guys answer this one. The researcher takes too many city roads. Ryan asks, so is a parameter of interest a detail about the population? That's a good way of understanding it, Ryan. The parameter of interest is like the characteristic of the population we want to understand. That's a good way of describing it. It's like you want to understand US voters, so you ask them who they're going to vote for. The population would be US voters, and then who they're voting for is the parameter of interest, because that's what we want to understand. You work for let's say Mars and you're making candy bars. So you'd want to understand your candy bars, and maybe you want to understand the proportion of packages that are defective, because maybe some of your packages rip open during shipping. So you'd say, okay, we want to understand our candy bars that we're shipping out, the population, and then we want to understand from them what % of them are improperly packaged. So the population would be all of your candy bars, that's what you want to understand. And then the parameter of interest would be, what is the proportion that improperly open during shipping? Alex, thank you. I love that 78 people are still watching. So good to have everyone here. So when you take too many of something, you would actually undercover because you take too many. So let's review what these biases are. Undercoverage is taking too much or too little of something. If you worked at that Mars factory right there and you had undercoverage, it might be that you took too many Hershey bars or too many Snickers bars. You don't want to take too many of something because you'll get too few of something else. If you have convenience bias, that's when you take the first 10 candy bars on the shelf. You're like, let's just look at the first 10. That's not random. Non-response bias really can't happen with the candy bars, nor can response bias. We'll talk about those in a second. How does the difficulty of this test compare to Kahoot? It's a Kahoot. Kahoots are a little different than the tests, so don't worry if you're not doing well in the Kahoot. Be taking notes on these and get the definitions. The Kahoot's a little different. Undercoverage can be both, or think of it that you didn't cover. And yeah, great job, Brian, right there. So it's undercoverage because you aren't covering enough of the rest of the roads. That is right, Jennifer, you got it. How is that undercoverage? Yeah, and no, Serena, it's a little bit of a trick right there. If you take too much of one, imagine I went out and took 90% freshmen. If I said my sample of students was 90% freshmen, you would tell me I did what to freshmen? I overcovered them, which means I did what to everyone else? There's like one drop left. I almost thought of buying 2 Red Bulls. So if anyone ever gets us that Red Bull sponsorship, that'd be amazing. Just put a Red Bull cooler in the back if UT will let me do that. So, but if you were to get 90% freshmen, exactly, the buffer is irking you, reload the page and hopefully, I'm sorry. And I think one of these days we might try to do it on Twitch or Mixer. I'm looking into Twitch or Mixer and that Red Bull sponsorship. So good stuff. And thank you guys and gals so much for being here tonight. You ready for the next one? Keep asking those questions in the chat. Keep asking those questions. We got Fearless Jaguar in the lead right here. Nice job, Fearless Jaguar. Oh, we have a simulation question. I hope I put 60 seconds on this. What percent of the time did you get 2 tails? Heads is 0 through 4. We got 60 seconds on this. This is a tough one. So what you need to do is you need to go to these numbers. Do you see where it says heads? Okay, good, I can click on it. Is 0 through 4. So that's a heads, that's a heads, that's a heads right there. We got 1 tails right there. Does everyone see in the simulation of 5 coin flips, we got 1 tails right there. How about in this simulation right here? I see a tails and a tails and tails right there, okay? Then in this, oh, wait a minute. That's 2 tails right there because those are numbers that are tails. How about this one? Ooh, that's 2 tails. I think we just found the answer. Remember, you can go back and review this, but you need to turn those numbers on the test into heads or tails. Yeah, we need to get the Twitch Prime subs. We can put that, I want to put that back into students. I don't know how they answered that quickly too. That's amazing if they did that. Oh no, Emily, I'm so sorry, I'm so sorry. I just figured it out. It is 2 out of 5, which is what? Did I put the right answer into this? Woo! I get afraid too, because sometimes I think I put the wrong answer in. I'm like, did I do the simulation right? I'm so sorry. But did everyone see how I did that? Please review if you're wondering how I did the simulation. Now, what would you do on the test? On the test, you need to go in here and you need to write in heads, 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 tails, heads. That was 1 tails in the simulation. Next, you need to go here and write in tails, tails, heads, tails, tails. I can't think. Tails, tails, heads, tails, heads. That was 3 tails in the simulation. Tails, heads, tails, heads, heads. That was 2 tails, which is one of the times we got 2 tails. That was one, that's a simulation right there that I've highlighted where I got 2 tails. Next we see tails, heads, tails, heads, heads. 2 tails, that's another simulation. Those were the 2 out of 5 simulations where we got 2 tails. So it didn't, I wish it said exactly, I should put exactly in on this. So it's on the test, we're usually more exact with our language. This is a Kahoot that I wrote for fun. And on the test, it should say exactly 2. So this one is, isn't it 3 out of 5 with 2 tails? So this is exact, unless I'm misreading it. I know that that second simulation right there has 3 tails, but if you were to say I flipped a coin and got 2 tails, I flipped a coin 5 times and got 2 tails, technically we would say this one, I flipped a coin 5 times and got 3 tails. Remember, in the Kahoot only lets me put so many characters in, so that's why these questions might be a little shorter than they would be on the test with context. So it doesn't have to be 2 in a row. No, so this question right here would be, here's the full test questions that we would write out on a test. You are flipping a coin to see if you get heads or tails. You flip a coin 5 times and count the amount of tails you get. How many times do you get exactly 2 tails? And so this one right here is not exactly 2 tails. This is 3 tails. So does everyone see, this is 3 tails right here. And the times you get 2 tails, unless I'm misreading it, are this one and this one. These are the 2 simulations where you get exactly 2. Good, I'm glad you guys see it right there. Sorry if the question was a little bit short on the wording. A lot of these max out the characters in what Kahoot will allow you. They only allow like 120 characters or something. So I had a hard time writing a full simulation question with simulation numbers. The big thing here is to understand how simulations are done. And then when you get a simulation, here's a big tip for the test. Put your work, no, sorry, Nicole. I'm sorry, Nicole. Put your work on the test. Write your numbers on the test. We tell the graders to grade based on the amount of work you do, so put your numbers on the test. Write out what numbers you're getting for the simulation and show your work. There'll be another one coming up with these same sort of numbers, so get ready for the next simulation question. Let's continue on here to the next Kahoot question. Where'd my mouse go? Let's go down here. There we are, mouse. It's hard to see a mouse on a white background. Fearless Jaguar, you're doing amazing. A researcher selects their sample based on the percent of highways, country roads, and city roads. This is a review question right now. So you're taking from country roads, highway roads, and city roads, and you're basing your percentages on those. You're saying, okay, Knoxville is like 40% highway, 40% city, and 20% country. So we need to take our sample based on those right there. We need to take our sample based on those. Like we're going to take 40% highway, 40% city, and 20% country. It sounds to me like I'm acknowledging a difference right here. It sounds to me like I am stratifying. Let's see, stratify. Yes, you know stratifying now. Good practice. Would dividing the full number of tails divided by 2 work? Not for that simulation, Taylor. Simulation's done a little bit differently right there. Thank you, Grace, for answering in on it. It's how many we got and how often did we get exactly 2 tails. I should have put exactly in that. So great question. We know what stratified is. Please ask questions if you have them in the chat right here. We're going for like another 30 or 40 minute calzone. You're welcome to come in here anytime and email questions if you have them. Thank you so much. So Fearless Jaguar, let's continue on. And when he's done, that's a good answer. That's what usually how we go. So we got Fearless Jaguar doing a great job. Are you in the Kahoot calzone? You might have to come down here and get your Starbucks gift card if you win. So that'd be so awesome, like someone wins from across the nation. The law of averages is a fallacy. What is the truth? The law of averages is a fallacy. I gotta go off screen. So the law of fallacies is not the truth. What is the truth? Here, I'll come back on. None of these are the actual answer. You don't need to worry about those. Those are lies. So you live 8 hours away. So you're a new guy. Good to have you, new guy. So good. Sorry, you got kicked, Mohammed. So what is the truth about the law of averages? Let's explain what the law of averages is. The law of averages states that if you're playing gambling, if you've lost in the past, you'll eventually win because you lose a bunch and then you'll win because you've been losing. But the truth is that past events do not influence independent trials. That's the truth. That if each game you're playing is independent, Serena, I like that. So past events do not influence independent trials. So past events do not influence independent trials. Like, imagine somebody is buying scratch-off tickets, and your friend buys 50 scratch-off tickets, and they're like, oh, I lost on all 50. I'm more likely to win on my next scratch-off ticket because I've been losing. Calzone, nice job. So is that true that someone would be more likely to win on scratch-off tickets if they've been losing a whole bunch? Like they've lost on 50 tickets in a row and they're like, man, I've been losing so much. My next ticket is more likely to be a winner. No. Scratch-off tickets are independent trials. Each scratch-off ticket does not care about the previous scratch-off ticket. So you can't say, I'm more likely to win because I've been losing on scratch-off tickets. No. So be careful. Don't gamble your money away. So win a flight to Knoxville here. Oh, you guys are cracking me up in the chat. Love it. Oh, a Fearless Jaguar. That would have been amazing, Calzone, if you're a Fearless Jaguar. So let's do this right here. Quiz time. Oh, I love this. You know those gross jelly beans, those Harry Potter gross jelly beans? So this is a really tough one. Yes, I have 120 seconds. Be writing this down. You need to take notes on this because this is a tough one. The probability of a gross jelly bean is 0.25. So the next thing, we got more New Yorkers here. I'm from New York. So the probability of a gross jelly bean is 0.25. What's the probability of a good jelly bean? 0.75. Be writing these down if you're watching this. Gross jelly bean, 0.25. Good jelly bean, 0.75. Now I want you to put 3 jelly beans in your hand right now. You're holding these 3 jelly beans. Now there's only 2 things that can happen. What do you mean there's only 2 things? One, either all the jelly beans are good or they're all bad. So you eat your first jelly bean. Your first jelly bean was what? According to the problem, it was good. So the first jelly bean's good, and then the second jelly bean is good, and then the third jelly bean is good. Now I want you to think about this. Do each of those jelly beans in your hand care about the previous one? Like when you eat this jelly bean and it's bad, the next jelly bean's like, wait a minute, I need to be good because that last one was bad. So what am I telling you by each jelly bean doesn't care about the previous one? They're independent trials. So since each jelly bean does not care about the next one, they're independent, which means we can do the multiplication rule. So wait a minute, the probability the first is good is 0.75, and the second is good is 0.75, and the third is good as 0.75. No, Serena, you did the probability that they're all bad. And so the probability they're all good, you might have realized it, is 0.75 to the third power. The probability they're all bad is 0.7, wait, let me make sure I said it right. The probability they're all good is 0.75 to the third power. The probability they're all bad is 0.25 to the third power. No, don't be salt. You're doing, so does that make sense right there? The probability is right there. The probability they're all good. So it should be, who can show it in the chat? 0.75 to the third power. Oh, thank you so much, Natasha, Natasha's mom. I am definitely a northerner. You can hear me say like water, daughter, twalk, and sometimes it'll come out. So good, and thank you, statistician right over there. That is awesome. My dad is also a statistician. He worked for Eastman, so in Kingsport. Worked for other places too, but that's where he finally retired. So does everyone understand right there? And did I do the math right? Please tell me if I did it right. I hope I did it right. I hope I did it right. People are saying in the chat 0.422, and that is 0.75 to the third power, because the first was good, and the second was good, and the third was good. Coffee, mall, say, I'll try not to stress it. Coffee, mall, water. The water, I got the D on the water. So if I stress it over, you'll hear it like water. But math was right. So we did it correctly, awesome, and I'm glad you guys are liking this right here. I have so much fun doing this. Thank you, everyone. Let's continue on to that next question, Margarita. Oh, the D at the end, I heard myself say it, Margarita. Margarita, not Margarita. Oh man, we all talk. Oh no, that's Boston? Boston. Which of the following is not a rule of probability? Which of the following, be careful, one of these sounds like a rule, but we call it, I'll give you a hint if you're listening, we call it the complement rule. There's a complement rule, but it's not called this. We have the addition rule, which says you can add together disjoint events. We have the multiplication rule, which says you can multiply together independent events. We have that all the probabilities equal up to 1, and we saw earlier that probabilities must be contained between 0 and 1, 0 meaning it can't happen, 1 meaning it must happen. And subtraction rule is not, and you got it. Subtraction rule sounds like the complement. I know it's a tricky question, but the complement would be 1 minus. Complement rule is you can say either A happens or it doesn't happen. Like what's the probability the Patriots win the Super Bowl? That would just be 1 minus the probability they don't win. So either they win or don't win, one of those must happen. Because either A happens or A does not happen. Those are complements. That's what complement is. We don't call it subtraction rule. A little tricky right there. Boston has parked the car at Harvard Yard. Yeah. Sometimes, I don't know. You guys might not know this, but my dream was to be a voice actor as a child. I love what I do now, but I always wanted to do like Batman, the animated series. Oh man, can I, here, wait. I'll show it at the end. Let me just give a shout out to Jason. We're gonna do a mid-Jason shout out right here. You ready for mid-Jason shout out? 2 seconds, let's hop into this. I'm a little jealous because this is Jason doing this voice right here. You ready? This is Jason.
It's not the question you deserve, it's the one you need.
That's Jason did that, and he did such an excellent Batman, so I am mad jealous at Jason. That's a really good Batman voice, so I had to hop back to the main screen. That's where that one's at. So a little shout out to Jason right there. Jason, everyone's big fans of you. Jason is my, I don't know who's Batman or Robin, but I got the Batman watch, so there you go right there. And let's continue on. Let's do it. Next, we got Fearless Jaguar still in the lead. Fearless Jaguar, you're doing a great job. The researcher is only collecting the average amount of potholes per mile. Ooh, this sounds like what they're interested in. I'll give it away. So they're collecting on this. They're going to the roads, and this is what they're collecting. It's what they want to understand. I'm basically giving it away here more and more, because whatever they try to... you want to win my Google Play gift card and all this stuff? I might be able to get away with that. So dress up as Batman for wedding. So we have here, this is the parameter of interest. The parameter of interest is, actually I probably would. You are correct. Calzone, if you won, I would mail it to you. You have my word for that. So I would definitely, we can let a random person in here. We could let them, if they win, congrats to them. So no, don't worry. Remember, be writing. Wow, Calzone, nice job. So remember, be writing these down. Have flashcards out, be taking notes. The parameter of interest is what we're interested in collecting about the population. The parameter of interest here is what we want to understand. Don't worry if you're doing badly. A lot of this Kahoot is more kind of conceptual. On the test, you will have to write out your answers more often. It looks like we have a little over 100, maybe 120, 130, but parameter of interest is what we want to understand about the population. So please make sure, ask those questions in the chat if you have them. Let's do the next question here. Remember, this is just review. A lot of it's conceptual. To multiply the probability of event A and event B, they must be what? This is a review question again now. To multiply two events together, they must be what of each other? Remember, the rule of multiplication says that two events must be this. Here's a hint. There's only one right answer. Now, I'm not giving the answer away right now. Disjoint and mutually exclusive are the exact same thing. Disjoint and mutually exclusive mean if one happens, the other can't. Those aren't the answers. So we're left with these two over here. We have dependent and independent. And it is that they need to be independent. Nice job. Independent is the multiplication rule. So are you taking intro stat, Calzone? Thank you for telling us about your what you're doing. I guess you're doing the same topics you said. So you are getting a good review right here. Tell people, be like, hey, check out Stat 201 if you want. We have no ads on our videos. We're just here to help, and I like people checking it out. What would you say the level of difficulty is on the exam? I'd say this one's a little bit harder. It's a little bit harder, but the good news is that the topics on the third exam kind of build off of this. So I know that sounds scary, but here's the good news. If you do well on this exam, or if you are following along, I had a student who made like a 60 on the first exam, a 60 on the second exam, and then they aced the final and they made a B in the class. So they kept just working on it. And I think it was in people's recommended. When we have enough people watching, we start showing up in recommendeds because YouTube's like, hey, this channel's showing up. So people might Google Kahoot or stats, and the things we put in the tags can show up in people's recommendeds. And so thank you, everybody. So everything right here, I think we got everything answered. So now let's continue on to the following next question. The researcher is unable to get information on certain roads, so they can't get information. They literally can't get it. They can't get it. They can't get a response. They don't get the info. It's not like the road literally doesn't give them a response, but the road they don't get info on. They can't get it. So think about this. If there's roads you can't get to, might those roads differ in what we know of what would be about them, like the potholes? Think about it. If you can't get to a road, it might be a harder road with more potholes. This is non-response bias. So it's that they're unable to get it. Let's define this. Can you give me hints during the test? I wish I could. Non-response bias, it's like when you call someone on the phone and say, hey, we're doing a survey, and they just hang up the phone. So non-response bias is when the people or things that you can't get information on differ in some way than the rest of what you're trying to get info on. So since we couldn't get info on them, that's a non-response bias because we can't get info. Response bias is when the bias is in the response. So response bias is when it'd be a little hard for a road to give a response bias, but when you ask somebody like how much income they make, or questions on our homework assignments, things like, do you think, and this is the classic example, do you think it's fair that you can go to war, that you can get married, that you can have kids, that you can own a dog and have a college degree at 20 years old, but you can't drink a beer? You'd be like, no, it's not fair. We should change the legal drinking age. Well, that's not a good way of asking the question. That gets a response bias because you're kind of prompting people to say something. That's response bias right there. Response bias is when the question leads to some sort of bias in the response, when the bias is in the response. So with this right here, asking a question like, do you think it is fair that this can happen? The legal drinking age should be this. You're pushing people to a response. You should just ask people, there we go. You should just ask people, should we lower the legal drinking age to 18? That's all we're trying to do right here. So we got that. Is this the best review you can get? So that is response bias. Under coverage bias and convenience, I think we did earlier. Great job on everyone doing the answers. Is it still Fearless Jaguar in the lead? Fearless Jaguar and Fuzzy Urchin, Fabulous, Oryx. I don't even know what an Oryx is. UT is 20% juniors. From 80 students, 30 are juniors. What is the mean of the sampling distribution? Ooh, good question. So remember earlier we saw mu p hat equals P. Mu P hat equals P. The mean for the distribution of the sample proportion is equal to the true proportion. Mu P hat equals P. So all you have to know for this, for the mean for the distribution of the sample proportion, all you have to know is P. Great job, you found it out. Mu P hat equals P. Where we lost people, I guess mu was a quick one. So this is mu P hat equals P. Does that make sense? Keep asking those questions in the chat. So if you have questions, feel free to ask it. This is the formula mu P hat equals P. It tells us that P is 20%, N is 80, and X is 30. So X over N, I believe, is what I wrote down here, is 0.045, but that is P hat. No, that wouldn't be P hat. P hat would be 0.375. I don't know what that's doing there. Because that is 3/8, which is 0.375. So P hat is 0.375. It says wrong on your screen. Yeah, well, 0.20 is P. Now, so does everyone see that? P and 0.80 would be Q, and 80 would be N. I don't even know why I have 0.045 right here. I don't see numbers that would solve for 0.045. Does that make sense? I think Megan was asking if I can explain this. Because it's the formula mu P hat equals P, because we want the mean for the sampling distribution, mu P hat equals P. So P is the answer, and P is 0.20. Because think about this. Okay, let me ask it this way. You ready? 20% of UT is juniors. Did everyone hear that? If you took a sample, what would you expect to see in 80 students? What percent would you expect to see be juniors? If you took a sample of 80 students, what percent in your sample would you expect to see be juniors? And that's the mean of the distribution, 20%, as Jennifer says right there. That's why it's the mean, because you would expect to see that. If 20% of UT is juniors and you took a sample, on average in those samples you'd expect to see 20%, i.e. mu P hat equals P. That stands for mu is kind of the expected value of your sampling distribution. What you expect to see when you get a sample is the truth. Imagine that 70% of people will eat Taco Bell in a week. You go out and talk to 200 people. What percent of them would you expect to eat Taco Bell? 70% of 70% of people will eat Taco Bell in a week. You talk to 200 people. What percent of them would you expect to have eaten Taco Bell if 70% of people eat Taco Bell? You'd expect 70%. That's why it's mu P hat equals P, because if you take a sample, you'd expect to see P, the true proportion. It's just saying 70% of people do this. Well, if I took a sample, I'd expect to see 70%. Now there's variation, i.e. P times Q over N square root, which is the standard deviation. Remember those formulas are on the test. People were asking about the formula sheet earlier. It's the exact same one on the practice test. So good review right there. 0.045, I bet that is P times Q over N square root, which is the standard deviation for the sampling distribution of the sample proportion. Fearless Jaguar in the lead. Review questions galore. Read the following rule as a sentence. Here's the clues. When you see addition, it's or. When you see multiplication, it's and. So think about this. We have the probability of event A, then there's a word, and then we have B, and then we have a word, and we have C. When you add things together, the word for addition I like to use is or. So the probability of A, or B, and C. That basically gives it away. I know he's doing amazing, Cal. So I'll just call you Cal for sure. Do you want me to call you Calzone or Tyrone? Whatever you like, I will call you. So, and thank you, you've been a pleasure in the chat. So, and all this is the probability of A, or B, and C. The addition rule is or, and those events must be disjoint of each other, and the multiplication rule is and. Those are the rules. Take a note on that if you want right now. When you see addition, it is or, and when you see multiplication, it's and. I'll call you Calzone. That just sounds cool. So let's continue on right here to the next one. Remember, ask those questions between questions if you have it. So let's continue on. Fearless Jaguar is doing amazing. A researcher decides to take 5-mile segments. Oh, sounds like they're taking a whole bunch of roads, and then they're sampling each 1-mile segment. So they're going to take 5-mile segments to kind of cut down on time. That's kind of sounds like a 12-pack to me of roads. It's like a 12-pack of rows. Great note in the chat right there, Elena. So we're taking a whole bunch. It kind of sounds like a dozen donuts to me, like they're taking a whole bunch at once. They're taking 5-mile segments, and they're sampling all the 1-mile segments within. So they want to get 1-mile segments, so they're taking a whole bunch at once. That sounds just like Clustering, good job. We're not tricking too many people. So clustering, oh no, didn't mean to trick you there. So this is clustering is what we have right here. Clustering is when you take a whole bunch at once, like taking a classroom of students, a 12-pack of Coca-Cola, or a dozen donuts. When you stratify would be like glazed versus filled donuts, business students versus arts and science students. What else do we say? We said soda, diet versus regular soda, because there's differences. You wouldn't take all of the diet soda, but you could take a 12-pack and sample the whole 12-pack, and that would be a cluster. Clusters are when you take a whole bunch at once, like a 5-mile road segment. You remember what the strata one? The strata one was country versus highway versus city roads. Now we're stratifying by a difference, where in clustering, we're taking a whole bunch of segments of roads at one time. So the difference here between clustering and strata is something we want to acknowledge. Good stuff. More questions. Is Fearless Jaguar still in the lead? Fearless Jaguar, amazing job, Fearless Jaguar. UT is 20% juniors from 80 students, 30 are juniors. Find the standard deviation for the sampling distribution of the sample proportion. That was find the standard deviation of the sampling distribution of the sample proportion, which is the sampling distribution we're talking about. I'm going to throw to my class, we're going to throw a big 20,000 points to the first person. You might not be winning the Kahoot right now, but I want to see you put the formula in the chat, and you should know it pretty quickly. It's P times Q over N square root. So you need to find P, you need to find Q, you need to find N, which is up there. And so in this problem, P is 30 over N, 30 over 80, which is N, which is 0.375. There you go, Kate, and we're giving it to Kate, Emily, and Jamie. So N, why not? Caroline also. Great job right there. P times Q over N square root. And it's quantity square root. It's quantity square root. It's the whole thing. Angela and here, Hyler and Jessica, thank you all right there. P is 0.375. How did I find that? 30 over 80, X over N. Q is 1 minus that, which is 0.625. So in this problem, it would be and so let's put in the chat, the formula, if I'm not mistaken, will be, let's do square root. Nice job, Alexis, you get the points too. Square root of 0.62, let's do P. I can't type today. 0.0375 times 0.0625, P times Q over N, and N is 80, and it's square root of this whole thing. P times Q over N square root. So that's it right there. Does everyone see that? P times Q over N square root. P is X over N. There were 30 students who are juniors out of 80. So the sampling distribution of the sample proportion would, oh my gosh, oh wait, someone's gonna say it. No, oh my gosh. Hey, great, Anna, oh my gosh. This is what happens when I've been going for too long. No wonder, we're gonna retract my message. I'm actually turning red a little bit. I made a mistake. Can I not retract my own messages? We didn't say that. So I got something wrong right here, and we saw it. The answer is not P hat. I kept saying P times Q over N square root, and I've been doing too much confidence interval stuff. This is the first error of the night. That is the answer right there. Would N be 80? N is 80, because that's how many people we sampled. So that is the first error of the night. We went 2.5 hours with no errors. Oh, we almost made it. So it is square root of 0.2 times 0.8 over 80. I kept saying it, P times Q over N square root. P is 0.2. We've been saying that through multiple problems. P is 0.2. Serena, who corrected me on it? I'm throwing another 20,000 to Anna. Anna, you got the equation right. You were the first person to type the right equation. And Serena also. I don't see your chats. Do you guys not see my Stat 201 chats? Oh, good. If you don't, that's great. Maybe I'm not connected to the chat right now. If you don't see my chats, that's probably why I wasn't able to make people mods, which is weird. Well, good. Then I never wrote the wrong equation in the chat. Never did that. It is P times Q over N square root, and we had the right equation here a moment ago. I know I'm doing the same. It's an easy error to make. Remember, it's P times Q. Write your notation on the problems. We were doing this correct earlier, but P is 0.2 and Q is 0.8. I don't know why my chats aren't showing up. I can't correct that live right now. Here, give me 2 seconds. We're going to try to correct Brian not seeing this. Okay, let me try to fix this real quick right here. Good, got the audio off on that. Let's try this. Hi. And now, can you guys see me in the chat now? Can you see that hi? Nope. Let's try sign into chat. That's weird. Ooh, don't wanna, I should not have. Can everyone still hear and see me? Okay, something weird happened. Okay, are we still streaming? Just tell me, are we still streaming? Are we still streaming? Don't worry if you can't. Okay, good. We're going to not worry about that. Yes, still streaming? Okay, cool. We will not worry about that. Let's not worry about that. So we will go right here and let's go over and let's put this. There we go. Okay, cool. You're still streaming. Good. Woo! As long as we're still streaming right here, as long as we are still streaming. Let me do this. Let me try one thing right here. Let me make sure. I think we can get. Okay. So. Okay, can everyone, let's try this again now. Let's go here and say hi. Okay, can everyone see me in the chat now? Oh, thank you guys so much. Can you see me in the chat now? Okay, cool. Awesome, we are back. Let's hop back over here and let's go back to the main screen. Okay, we got it, we're back. So, there we go. Thank you guys for, no wonder I didn't have mod powers. So, you know what? Do we still have, you know who's earned it? Are you still here, Calzone? Are you still here, Calzone? Anita, let's make you a mod. Add mod right there. Is Calzone still here? Calzone, are you here? Let's continue on to the next question. Thank you, Eric and everyone. The probability of getting a multiple choice question correct is 0.8. With 5 questions, what is the probability you get at least one wrong? The probability of getting at least one question wrong here. What is the probability of getting at least one question wrong? So everyone think about this. You get at least one question wrong. So okay, here's the 2 things that can happen. You will either get them all correct or you will get at least one wrong. Does that make sense? Does everyone see what I've done? You will get them all correct or you will get at least one wrong. So think about this. What is the probability if we add these 2 together? You will either get them all correct or get at least one wrong. So let's think right here. Probability is 1 for probability all right or at least one wrong. Does everyone see what I put in the chat right there? So now let's think about reorganize that equation. We want to figure out the probability you get at least one wrong. So it'd be 1 minus the probability of all correct. If everyone notices what we wrote in the chat right here, because you will either get them all correct or you will get at least one wrong. So you either get them all correct or at least one wrong. So now we need to figure out the probability of getting them all right. Well, you get the first one right, and the second one right, and the third one right, and the fourth one right, and the fifth one right. So with 5 questions, the mathematics would be this right here. 1 minus 0.8 to the 5th power. Because you got the first right, and the second right, and the third right, the fourth right, and the 5th right. Because you will either get all the questions right, or you will get at least one wrong. And read that equation. It's everything but getting them all correct. 1 minus means everything but. Everything but getting everything right is getting at least one wrong. Because you will either get them all right or at least one wrong, so we can subtract. This is a tricky one. Very tricky question. This is a tough one. So this, who understood that in the chat as we walked through it? Because remember, let's get to 100. That'd be so cool if we got 100 likes. I have no idea what we're at right now. So here's what we need to list. You do now? You got it? Yes. This is a tough one. This is a really tough one. Got it after I explained it? These are really tough. So what we have right here is, think about this. You will either get 0, 1, 2, 3, or 4 questions correct. So the reason we're raising it to the 5th, Mary, is because what is this probability right here? Probability of getting 1 right. So 0.8 is the probability of getting 1 right. 0.8 to the 5th is actually 0.8 times 0.8 times 0.8 times 0.8. So right here, this is, you get all 5 rights. Oh no. So right here is you got the first right and the second right and the third right and the fourth right and the 5th right. So that can be written as 0.8 to the 5th power, which is, we're fine if a dislike happens. I'm cool with that. Dislikes are actually interactions with the video, so by hitting dislike, you help our video. So 0.8 to the 5th power is you got all 5 questions correct. Does that make sense? 0.8 is you got every single question correct. And what's the complement of getting everything correct? Because you will either get everything correct or what? You'll either get all the questions correct or what? One of these two things must happen. You'll either get all the questions correct or, because we can do the complement, you'll either get all the questions correct or, and you can say it in the chat, you'll either get all the questions correct or you'll miss at least one. Those are the complement. You will get one, I like that right there. You will either get all the questions correct. And Serena, let's look at this. 0.2 raised to the 5th power means you got all the questions wrong. So you'll either get all the questions wrong or you will get at least one correct. The first probability I wrote is the probability of getting all the questions wrong. The second probability I wrote is the probability of getting at least one correct. And so read it. 0.2 to the 5th power is getting all the questions wrong. 0.5, so it is not that. So 0.2 to the 5th power is getting all the questions wrong. 1 minus 0.2 to the 5th power is getting at least one question correct. Wait, is it 1 minus? So the answer is, it's going to be 0.8 raised to the, why can't I type in the chat? 0.8 raised to the 5th power is getting all the questions correct. 1 minus 0.8 to the 5th power is getting at least one question wrong. So it's not the whole thing. Anna right there clarifies 0.8 to the 5th power is all the questions correct. 1 minus 0.8 to the 5th power is getting at least one question wrong. Does that make sense right there on how to do the mathematics with it? I think we got it. Let's continue on right here. Next question. The roads the researcher samples are the what? The roads the researcher samples are the what? The roads the researcher samples are the what? The ones they actually get a sample on. So think about this right here. The roads they actually get a sample on are the what? The roads they actually get a sample on. No. The roads they actually get a sample on are the what? The roads they actually get a sample on are the what? The roads they actually get a sample on are the what? They are the sample. Nice job. I think that one's pretty self-explanatory. No, don't want to see people getting them wrong. No. Let's Fearless Jaguar. Oh, Fuzzy Urchin, Fearless Jaguar. You guys will be coming by to pick up your cards here soon. Let's do this. Maybe, I don't know, researcher selects the first 20 roads next to their house. This should be kind of obvious. The researcher selects the first 20 roads next to their house. It could be, Ryan, these are a decent example of kind of quicker questions, and we're doing a lot of concepts. So we're doing a lot of conceptual questions right here to see if you can get the basic conceptual stuff. These are a lot of conceptual questions right here. The first 20 roads next to their house. They select the first 20 roads next to their house. It would be what? Definitely convenience. Everyone got that. We know what convenience is. The first 20 roads next to the house is convenience. And next we have here, we know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is N? This is a quick one. We got this. Just like 30. So just like 30 more likes. What do we have right here? We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. Now I want to point this out. On the test, write your notation on the test. I wish I could write on this. I'm going to do it. It won't let me write on it, of course. But put your notation on the test. You just tried to click the answer on the video. Wait, so did I, and why did we do that? Wait, I'm so confused, Emily. I am so confused. Oh, everyone clicking the video. Cracking me up right there. Everyone's like, I got it. Touch the screen, got it. I wish that'd be so cool if YouTube integrated this. If YouTube integrated a way to do it on touchscreen, that'd be amazing. Like, there's probably a way, but I don't know, involve the two. Wow, Fearless Jaguar and Fuzzy Urchin. It's a neck and neck race right there. The probability of making a shot is 0.30. What is the complement? We get to play the P and the Q game. If P is 0.1, Q is 0.9. If P is 0.2, Q is 0.8. If P is 0.3, what is Q? P and Q are complements. They must add up to 1. Anytime you want to find Q from P or P from Q, you just do 1 minus. It's whatever adds up to 1. So all we need to do right here is do P and Q and find the complement. So what is the complement of 0.30? And it is definitely, yes, I like seeing that 100%. That's when we're doing clickers in class. I'm like, yes, good job. Amazing work, everybody. Keep it up. Fearless Jaguar and Fuzzy Urchin, you got it. Two events that can be easily added together must be what of each other? Two events that can be easily added together must be what of each other? Two events that can be easily added together, error for 5 run. Two events that can be easily added together must be what? I believe there should be 2 answers. Answer disjoint unless I forgot to put in 2 answers. Two events that can be easily added together are what? Two events that can be easily added together are what? There should be 2 answers here. If they can be easily entered together, they can be what? They are very, very much events of each other. Yes, there was 2 answers. This is a review question. Now I see a lot of people getting it wrong. When events are disjoint or mutually exclusive, we can add them. So when they can be added, remember, independent. So now think of this. Dependent, it is true that disjoint events are dependent. But think about this. Can it snow and can we also have school? So school depends on snow, right? But I know this is confusing, so this is where people are getting tricked. Disjoint events are dependent. Are all dependent events disjoint? Can it snow and can we also have school? Can it snow and can we also have school? The answer is yes, meaning that snow and school are not disjoint events. So we can snow and have school, but does snowing change the probability of school? Does snow change the probability of school? And the answer is yes. Oh, okay, good. So disjoint events are events that can be easily added together. Disjoint is also known as mutually exclusive. Independent events are events that can be multiplied together. Disjoints equals add. I can see the D's in there for disjoint. And independent means you can multiply. So disjoint events can be added together. In independent events can be multiplied together. So it is true that disjoint events are dependent, but not all dependent events are disjoint. As in, school depends on snow, but you can have school and snow at the same time. I.e., snow and school are dependent events. Having school depends on snow, but it can snow and you can have school, meaning they are not disjoint. But making an A depends on a B, meaning they are dependent, but you can't make an A in a class and make a B in that same class the same semester, meaning that they are disjoint. You can't have A and B in same class, same semester. So all disjoint events are dependent, but not all dependent events are disjoint. Ryan, you get 10,000 points right there for my class. Great answer right there. That is true. All disjoint events are dependent, but not all dependent events are disjoint. Perfect answer right there. Great answer. Fearless Jaguar and Fuzzy Urchin. Fearless Jaguar is pulling away for the sampling distribution of the sample mean. What is the third condition? Condition 1, it's not condition 1. The third condition is one of these 2 right next to me. Wherever the conditions are, it's one of these 2 right next to me right here, giving it away a little bit. Condition 1 is random. Condition 2 is 10%. And condition 3 depends on what distribution we are doing. If it's the sample mean, that's quantitative, meaning we probably want things to look kind of normal. And if it is categorical, we'd be dealing with proportion. Like Alex and Eric are cheering it on. So we have here the sampling distribution of the sample mean. The third condition is, ooh, that's close. Write this note down. So write this down. Calzone, here's your prize right here, Calzone. You're a mod now. So I think you've earned it. We trust you. You're good. So right here we have the third condition. How do you know it's large enough? It's large enough because we are dealing with a quantitative distribution. So please, I think I have some notes on this, and we did review it last class. But what we have right here is the sampling distribution of the sample mean requires that it's large enough that the distribution becomes normal. We did some problems earlier in the video on this where we did the sampling distribution of the sample mean. Got that, Eric. And so we also need to know for the sampling distribution of the sample proportion that we meet the success-failure condition. This one right here means we need at least 10 successes and 10 failures. Success-failure is for what kind of data? Proportions, which are what? Proportions are what kind of data? They're not means, they are categorical. So Calzone, you're a fan favorite here. So proportions are categorical with the third condition being success-failure. Means are quantitative where we're doing the large enough n condition. So these are good notes to take. When you see sampling distribution of sample mean, third condition is large enough n. When you see sampling distribution of sample proportion or confidence intervals for proportions, the key word in these questions is what? I want you to say it. When you see success failure, it's dealing with what kind of questions? I'm pointing down here at it. When you see success failure, it's dealing with what kind of questions? When you see success failure, it's dealing with what kind of questions? It's proportions, it's categorical. You're right, you'll see proportions. It'll have to be like, are people juniors? Are they seniors? Do they like Taco Bell? These are all categorical. These are things like waist sizes or waitress tips or things like this. This is if someone will default on their bank loans. This is how long do pregnancies last? This one is, are children nearsighted? This one is, what are the car emissions? You see, as I'm saying, quantitative car emissions, will people default on bank loans, categorical. Does everyone see the difference right there? Success failure deals with proportions, which is categorical, and the top one here is quantitative, which deals with means. Taco Bell bonus on the test. Oh man, we should get Taco Bell bonus. But the other two are the same for both, right? Yes, random. Did we randomly select our data? Less than 10%. Did we get less than 10% of the population? We got it. So good answers and good questions right there. Continuing on, we have Fearless Jaguar and Fuzzy. Fearless Jaguar just catapulted to the lead. Wow. For the sampling distribution of the sample proportion, what is the third? You got this now, you got this. The sampling distribution of the sample proportion, what is the third condition? The sampling distribution of the sample proportion, I'm going to jump out of my box right here. The sampling distribution of the sample proportion, what is the third condition? What is the third condition? What is the third condition for the sampling distribution of the sample proportion? What is the third condition for the sampling distribution of the sample proportion? So what is the third condition for the sampling distribution of the sample proportion? I'm just keep saying that. When you hear proportions, you should think success failure. Woo! Success failure. There we go. Last question, then we're gonna head off. We've had a good time today. We've done was it a 2.5 hour stream? 2.5 hours. We got this. This is it. Or no, 3 hours. Oh my gosh. Oh no, what percent of the time did you get 2 heads? So now we got to do it. It's not, don't count if you got 3 heads. You want to see exactly 2 heads. The question is exactly 2 heads. Let's do the simulation. Heads, 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 tails, heads. Did not get 2 heads. Heads, oh my gosh. Tails, tails, heads, tails, heads. Wait a minute, that's 2 heads right there. Tails, heads, tails, heads, heads. Nope. Tails, heads, tails, heads, heads. I'm using the numbers over here in case anyone's wondering. Then this one is tails, heads, 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 all heads, because heads are these numbers here. So it looks like the only time we got 2 heads was in this simulation right here. That simulation right there is the answer, which means it's 1 out of 5. 1 out of 5 simulations got it. And we've done a 3-hour stream. Woo! Check out the review, email those questions. I'll probably be heading off. Fuzzy Urchin, I think, is the winner. They get the $10 Starbucks gift card. So that is the answer, 1 out of 5. And Fearless Jaguar, wait a minute. Oh, it's Fearless Jaguar. Fuzzy Urchin was second. And Silver Wombat, So, and only one Red Bull, impressive. I know, more Red Bull is what we need right here. Tiniest sip left. Coconut Red Bull, best Red Bulls there are. Thank you so much. Yeah, anytime, Ryan. Feel free to email those questions. So, calm down, Eric. We're good, we're good, we're good, we're good. No, it doesn't taste like coconut for some reason. It actually tastes good, which I'm not a huge fan of coconut. It's like coconut berry. It's actually pretty good. But that's got it. So email me those questions if you got it. Remember, be watching the videos. I want to point out something. Give me 2 seconds right here. If you're watching this video, how many people do we still have watching on the video? How many people do we still have watching? Let's go back over here. 139, wow, amazing. So if you notice right here, we're on our page. What you'll notice is the exam in the same location. Yes, it is for our class. Make sure, so just keep checking. Calzone, my email is bstevens@utk.edu. So thank you so much for being here. That's the email right there, bstevens@utk.edu. I am Brian Stevens. Do the waitress question. I think, Gabe, do we have that in the previous video? Can anyone send a timestamp? Can someone put a timestamp in the chat right now to the waitress question? I might be able to do it. You might hear a reverb on it. So I'll throw 10,000 points. It's in the previous video. Sydney, can you find that real quick? You should throw us extra credit points. 1,000 for being here, 1,000 extra credit points for being here right now. When is the next stream? I don't think we'll be streaming tomorrow, but maybe. I have to, maybe. There might be a surprise stream tomorrow, maybe. Who knows? But we're glad to have you. And then, yeah, we should stream tomorrow. We might be able to. We might be able to. I'll be running around a bit. I might try to see if I can get on here and stream. Which does the second and third get a prize? Yes, they do. Second and third get a prize. They get $5 Starbucks gift card. Does anyone have the link in the chat to... Let me hop back over here. What I want to point out is the following. We're probably losing people very quickly right now. With the exam prep, there you go. Hey, Calvin. So if you look right here, here's the latest review. Did we review it? Let me turn off the sound on this. Did we do the question right here? Did we do the waitress one last class? This was review stuff. Did anyone drop the link in the chat? Guess who won? Did you win, Calzone? Did you win? Did you win? That'd be crazy. So you'll notice all the review stuff. Did anyone find the link? I'll hop back over to here. We'll find the link. Let me get the link up. People are asking about the waitress question. Okay. We did in chapter homework. Okay, let me do that. You guys might be, let me turn off system audio. Probably hearing the YouTube commercials that I have going on in the background. Okay, YouTube Studio. Could you guys, okay, let me hop over to my videos and let me grab it. I will put the link for the, if you ask for like one of the questions, I'll put it here. There it is, okay. And I think I sent it out this morning too, but for anyone who doesn't have it, okay, 2 seconds. Let me find the waitress one. Here we go. Oh, here it is. Found it. Okay. Since we've already done it, it's the same thing as me doing it right here. Okay, cool. Copy of video URL, current time. Okay, here we go. So there's the link right there. The loan question. Did I do the loan one last time? I tell you what, we'll do the loan one to end class. How's that sound? So we're gonna do the loan question to end class. So this is gonna be the last question right here. Let's do the loan question. Okay. So I'm gonna pull up the loan question right here and we'll do the loan question to end class. The loan question to end class. Aha, found it. Okay. Let's do the loan question in class. Chapter 14, sampling distribution, sample mean is on the test. This is sampling distribution, sample proportion. So, don't worry about it, Alex, there. Don't worry, good. Okay, so let's do this one to end class. This will be our last question. Thank you for staying the whole time. I really appreciate it. This is what we want to practice right here. If you notice it says mu p hat, we go to our formula sheet and what do we see? We see where it has mu p hat, we wrote that earlier. On our formula sheet, we would get, we wrote it down earlier, let's go to where, we'll write it new. And we'll go formula sheet. Can't decide. Mu p hat is equal to, here's where we wrote it, mu p hat is equal to p, and standard deviation of p hat is equal to p times q over n square root. So if you notice these blue things next to me right here, we have mu p hat equals to p. And what does that mean? It means the following. If we were to talk to, how many people? 300 people, and 11% of them are expected to default on their loans, then what would we expect to see in a sample? Well, 11%. Because if 11% of people default, then we'd expect to see 11% default. What we have right here, now we need to find the standard deviation, which is p times q over n square root, not p hat. 0.11 times 0.89, p times q over n, and then square root. All I did was, and how did I find q? Is I did 1 minus p. So p times q over n square root. Does that, and I didn't square root it yet, did I? Or did I already do all that? I blacked out and just like did it. So that was p times q over n square root. I think I did it all. That was the formula p times q over n square root. I'll say that a few more times here. We're just deleting down the decimals down to 3 decimals. So this is now 3 decimal place accuracy on our standard deviation for the distribution of the sample proportion. Once you have all of this and you meet all the conditions, which 1, 300 people is less than 10%, or 1, we give random loans. It doesn't say it, but we'll assume. And then 2, we sample less than 10% of the population, and then which 300 loans is less than 10% of all loans that could be given. And then 3, we need to have at least 10 successes and at least 10 failures due to NP and Q. To do NP and Q, we do 0.11 times 300. There's NP, and NQ would be 267, because NP and NQ add up to N. But we could check that by doing 0.89 times 300, and whoa, 0.89 times 300 is equal to this right here. I hit a wrong button. So both NP and NQ are greater than 10, meaning we pass the success failure condition. Why is the third condition here success failure? It's success failure because it's sampling distribution of sample proportion. So that's the key right here. This is the sampling distribution of the sample proportion, and that's what we have going on. So we're going to take all of this data right here. Let me look at this. What is the z-score on that going to be? I can almost guess this one. Let's end it with a guess. 0.273. Did I get it right? I'm just taking a guess. If anyone's like, you didn't get it, Brian, I'm just taking a guess. You can't see my check answer thing on here. Let me remove the dark screen. There we go. It's back now. Check answer, did I get it right? I like taking guesses on these. If I got it wrong, it's just a guess. I got it wrong, it looks like. Let's go in and do it the right way by taking that standard deviation and going over to the David M. Lane applet. And this would not make a good test question here unless we gave you an empirical rule number. Remember 0.11 did say less than or greater than. I gotta make sure I put in the less than or greater than. If you notice, I'm just putting these into the distribution right here. And it might have said less than, but let me check. What did it say, less than or greater than? So if you notice, we've drawn the sampling distribution of the sample mean, and now let's look at the question again. It said, what is the probability over 12%? So we go here, and we go above 12%, and the answer is that's gonna be like 33%. I was 28.99%. I was close-ish. It was 28.9, and it was 99, but it has enough leeway usually that it gives it to you. So that is correct. I took a guess. I was just guessing at it. So that's why I was wrong, because I took a guess. Let's move me back down. That's not my move button. Where's my move button? There we go. Let's move me back down to here. No, there we go. That's got it. There you go. There you go. Here I'm gonna, there we go. Up. So there you go. Take it down. I'm gonna remove the chat here in just a second, so that way it's not in the video. But thank you. Did everyone get that who wants, or there you go. Here we'll remove these from, this is a public video, so I'm gonna remove all the chats with those in there since this is a public video. Let me do this, wait, how do I, so retract the messages if you guys want, since it is in just a public video, because these are out there just, as long as you're cool with that, but just, if you wanna retract it, just retract it, like you guys are cool with that. If you wanna, you can click the thing on it, but what did I do? I don't know what I did, Alex. But here, wait, how can I not do that? Does YouTube have a message system email? Making connections right here. I have no idea what's going on. I'm so confused. Okay. All right, so are we all good right here? Is everyone good? It is time, I think. So it is time. Thank you everyone for being here. Calzone, you didn't get to see it, so we're gonna play our outro, Calzone. You get to see our cool outro, then we'll end class. Here we go with one of our intro screens, but we're making an outro today.
Like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.